Imagine a world where the asteroid that struck Earth 65 million years ago had missed its mark, leaving the dinosaurs to continue their reign over the planet. In this alternate history, the massive extinction event that wiped out approximately 75% of all species, including the non-avian dinosaurs, never happened. Without this cataclysmic event, the trajectory of life on Earth would have unfolded in a vastly different way. The dinosaurs, which had already dominated the planet for over 160 million years, would have had the opportunity to further evolve, adapt, and diversify into new niches, potentially giving rise to even more complex and specialized forms of life. The absence of the extinction event would mean that mammals, which were small and relatively insignificant during the age of dinosaurs, might have remained in the shadows, unable to rise to the prominence they eventually achieved. Without the ecological vacancies created by the extinction, mammals would have faced fierce competition from the dominant dinosaurs, possibly preventing them from evolving into the diverse array of species, including humans, that eventually came to populate the Earth. In this alternate scenario, dinosaurs might have continued to evolve into even more specialized forms, perhaps developing higher levels of intelligence, social structures, and complex behaviors. Some paleontologists have speculated that certain species of dinosaurs, particularly the theropods like the velociraptor, already exhibited traits that could have led to the development of more advanced cognitive abilities. Given another 65 million years of evolution, it's not impossible to imagine a world where these creatures could have developed tool use, complex communication, or even the rudiments of culture. The climate and geography of Earth would also have been different without the massive changes brought about by the asteroid impact. The extinction event triggered drastic shifts in climate, with the initial impact causing a global nuclear winter effect, followed by a longer period of warming due to the release of greenhouse gases from volcanic activity. In a world where this impact never occurred, these changes might not have happened, leading to a more stable climate that could have supported even more diverse ecosystems, potentially with the dinosaurs spreading to regions they never inhabited in our timeline. Moreover, the evolutionary path of plants would have been different as well. Flowering plants, which began to dominate after the extinction of the dinosaurs, might have evolved at a different pace or in different directions, influencing the types of ecosystems that developed. This could have further shaped the evolution of dinosaurs, leading to new species adapted to these different environments. In this alternate history, the rise of intelligent life might have taken a different form entirely. If the dinosaurs had continued to evolve and diversify, one could imagine a world where intelligent, reptilian-like creatures emerged as the dominant species, developing civilizations that might resemble those of early humans, but with a distinctly different appearance, culture, and technology. The world could have been a place of towering cities built by these advanced dinosaur descendants, living alongside a diverse array of other dinosaur species in a planet teeming with life and activity. This scenario also raises questions about whether humans would have ever evolved at all. If the dinosaurs had not been wiped out, the evolutionary pressure that led to the rise of mammals might not have occurred, meaning that primates and eventually humans might never have existed. The absence of humans would mean that Earth's history would be devoid of the technological advancements, environmental impacts, and cultural developments that define our current timeline. Instead, the planet might be ruled by a completely different form of intelligent life, with its own unique challenges, achievements, and struggles. The possibilities are as vast as they are fascinating, painting a picture of a world both familiar and alien, where the dominant life forms are the descendants of creatures that, in our timeline, became the stuff of legends. Considering a world where dinosaurs continued to survive and thrive, their dominance would have significantly influenced the evolution of other species that emerged around the same time. With dinosaurs maintaining their place at the top of the food chain, many of the smaller mammals, reptiles, and birds that were beginning to diversify during the late Cretaceous period would have faced a vastly different set of challenges. These species would have needed to adapt in ways that either allowed them to coexist with the larger, more powerful dinosaurs, or to exploit ecological niches that the dinosaurs did not occupy. For mammals, this might have meant continuing to evolve primarily as nocturnal or burrowing creatures, avoiding direct competition with the dinosaurs for resources. In such a scenario, mammals might have remained relatively small and specialized, with evolutionary paths that focused on survival strategies like speed, stealth, or dietary specializations rather than growing larger or becoming more dominant. The pressure to develop larger brains and more complex social behaviors, which were key in the actual evolution of primates and eventually humans, might not have been as strong in a world still ruled by dinosaurs. Instead, mammalian evolution could have followed a path more akin to that of marsupials in Australia, where many species remained small and adapted to specific niches due to the presence of larger, dominating species. Similarly, birds, which are descendants of certain dinosaur species, would have likely continued to evolve but with a greater emphasis on aerial and arboreal lifestyles, as these environments would have offered refuge from ground-dwelling predators. In this alternate timeline, we might see an even greater diversity of bird species, with more dramatic adaptations for flight, such as larger wingspans, enhanced maneuverability, or even greater intelligence for navigating complex environments. Birds could have filled the ecological roles that mammals took in our timeline, becoming the primary small to medium-sized animals that adapted to various habitats around the globe. Reptiles, too, would have had to carve out their evolutionary niches in a world dominated by their larger dinosaur relatives. Smaller reptiles might have focused on becoming highly specialized in their diets or habitats, perhaps evolving unique defense mechanisms, such as more potent venom or camouflaging abilities, to survive in the shadows of their dinosaur counterparts. Some reptiles could have taken to the water, evolving into marine species, or even reoccupying the niche left by the ancient marine reptiles like plesiosaurs and ichthyosaurs, leading to a world where reptiles play a much more significant role in both terrestrial and aquatic ecosystems. The continuation of dinosaur dominance could have also influenced the evolution of insects and other invertebrates. With large herbivorous dinosaurs shaping the plant life and ecosystem, insects might have evolved to be highly specialized pollinators, decomposers, or parasites, depending on the available flora and fauna. Some insects could have evolved symbiotic relationships with certain dinosaur species, while others might have developed more robust defenses against being trampled or eaten by these enormous creatures. Overall, the survival of dinosaurs would have created a world where the evolutionary paths of many species would have diverged significantly from what we know today. The ecological pressures exerted by these dominant creatures would have shaped a planet filled with specialized, highly adapted species, each one finding a way to thrive in the shadow of the giants. This alternate evolution would have produced a biosphere that, while still diverse, would look very different from the one we see today, with the influence of dinosaurs continuing to echo through the ages. Imagine a world where the asteroid impact 65 million years ago still unleashed its devastating effects. Massive fires, dust clouds blocking out the sun, and a dramatic drop in temperatures. But somehow, against all odds, the dinosaurs managed to adapt and survive. This scenario would have created a planet where the environment was harsh and unforgiving, but the dinosaurs, through sheer resilience and perhaps some evolutionary innovation, found ways to endure the climatic upheavals that followed the impact. In this alternate history, the dinosaurs that survived would likely be those with the greatest adaptability to extreme conditions. Smaller species with more diverse diets and those capable of enduring colder climates might have had the best chances of survival. For instance, some dinosaurs could have evolved to become more like modern-day cold-blooded reptiles, slowing down their metabolism to cope with the reduced availability of food and the colder temperatures. Others might have developed insulating features like feathers or thick skin to keep warm during the long dark winters that followed the impact. The survivors of this catastrophic event would have faced a drastically altered world, with the lush tropical environments they once knew replaced by more barren, inhospitable landscapes. Vegetation would have been sparse, forcing herbivorous dinosaurs to adapt to eating tougher, less nutritious plants, or to become more omnivorous, broadening their diets to include whatever they could find. Carnivorous dinosaurs, on the other hand, would have needed to become more efficient hunters, possibly developing pack behaviors to bring down prey more effectively in a world where food was scarce. As the climate gradually began to stabilize, these dinosaurs might have slowly repopulated the Earth, but their forms and behaviors would be significantly different from the giants that roamed before the asteroid hit. The pressures of survival in a post-impact world could have driven rapid evolutionary changes, leading to the emergence of new species better suited to the changed environment. We could imagine a world where dinosaurs became smaller, more agile, and perhaps even more intelligent, as these traits would be advantageous in the challenging conditions they faced. The continued presence of dinosaurs would have had a profound impact on the evolution of other species as well. Mammals, birds, and reptiles, all of which were beginning to diversify around this time, would have continued to evolve under the shadow of these formidable survivors. The ecological niches that opened up after the impact would have been fiercely contested, with dinosaurs likely outcompeting many other species for dominance in various habitats. This would have limited the opportunities for mammals and other creatures to evolve into the roles they eventually occupied in our timeline. In a world where dinosaurs adapted to and survived the post-impact climate, Earth's evolutionary landscape would be markedly different. Mammals might have remained small and nocturnal, birds might have evolved to become even more specialized to avoid competition with the dinosaurs, and reptiles could have followed entirely new evolutionary paths. The dominance of dinosaurs would have continued to shape the planet's ecosystems, perhaps leading to a world where they remained the top predators and herbivores for millions of years longer than they did in our reality. This alternate scenario paints a picture of a world where the asteroid impact did not mark the end of the dinosaurs, but rather a new chapter in their evolutionary history. It would be a world where the adaptability and resilience of life are on full display, showcasing how species might evolve in response to even the most extreme challenges. If the mass extinction event 65 million years ago had not occurred and dinosaurs had continued to thrive, the evolution of plant life would have taken a dramatically different path. Flowering plants, or angiosperms, which began to dominate the Earth's flora after the extinction, might not have risen to the prominence they hold today. Without the drastic changes brought by the asteroid impact, the landscape would have remained largely dominated by the plants that were already well established during the age of the dinosaurs, such as conifers, ferns, and cycads. These plants, which were better suited to the climate and conditions of the late Cretaceous period, might have continued to flourish, maintaining a firm grip on the planet's ecosystems. In this alternate history, the evolutionary pressure on plants to adapt to a rapidly changing environment would have been less intense. The mass extinction event created opportunities for flowering plants to expand and diversify, filling the gaps left by the dying off of other plant species. But if these gaps never existed, angiosperms would have faced more competition from the already established plant species. As a result, the pace at which flowering plants evolved and spread across the globe might have been significantly slowed, or they might have remained a more minor component of the Earth's vegetation. The absence of a flowering plant boom would also have influenced the evolution of other life forms that rely on plants, including insects, birds, and mammals. Many of the mutualistic relationships that developed between flowering plants and pollinators, such as bees and butterflies, might not have evolved at all, or they might have taken different forms. Insects might have continued to specialize in pollinating gymnosperms like conifers, or feeding on the more primitive seed ferns and cycads, leading to a very different structure of plant-insect interactions. Similarly, herbivorous dinosaurs, which already had diets centered around the dominant plants of their time, would have continued to shape the plant life through their feeding habits. Large sauropods, for example, might have further influenced the spread and success of certain non-flowering plants by acting as major agents of seed dispersal or by pruning the landscape in ways that favored the growth of specific plant species. This close interaction between dinosaurs and the plant life of the era would have created a stable, yet slowly evolving ecosystem that persisted without the dramatic shifts that flowering plants brought in our timeline. The evolutionary trajectory of Earth's forests and other plant communities would have been much more gradual, with less diversity in flowering plant species and more dominance by ancient plant forms. Forests might have continued to be dominated by tall conifers, with ferns carpeting the forest floor, creating a more uniform and less colorful landscape. This would have influenced the entire biosphere, from the types of habitats available to animals to the composition of the atmosphere, as different plants produce different amounts and types of organic material. In this alternate scenario, the world would be a place where the lush, diverse forests filled with colorful flowers, fruits, and broad-leaved trees we know today might not have existed. Instead, the Earth would have been home to more somber green-brown landscapes dominated by towering conifers, sprawling ferns, and other ancient plants that shaped the lives of dinosaurs and other creatures in ways that are now lost to time. This would have been a world where the evolutionary leaps forward driven by the rise of flowering plants never happened. resulting in an Earth that evolved along a slower, perhaps more predictable path, with ecosystems that were stable yet far less diverse than those we see today. If marine reptiles like plesiosaurs and mosasaurs had survived the mass extinction event 65 million years ago, the oceans of Earth would have remained a realm dominated by these formidable creatures, creating a vastly different marine ecosystem from the one we know today. These apex predators, having already established their dominance in the prehistoric seas, would have continued to thrive and evolve, shaping the aquatic world in ways that would have left little room for the marine mammals and other species that came to prominence after their extinction. In this alternate scenario, plesiosaurs, with their long necks and powerful flippers, might have evolved to become even more specialized hunters, perhaps developing new strategies to capture prey in the deep, dark waters of the ocean. Their physical adaptations would have allowed them to remain top predators, capable of taking on a wide variety of marine life. Mosasaurs, on the other hand, known for their speed and ferocity, would have continued to rule the open seas, hunting large prey and keeping the population of other marine species in check. The presence of these giant reptiles would have had a significant impact on the evolution of fish, cephalopods, and other marine animals, which would have needed to develop new strategies to survive in an ocean still teeming with such powerful predators. The survival of these marine reptiles would also have influenced the development of marine ecosystems, potentially preventing the rise of many species that became dominant in our timeline. Whales, for example, which evolved to become the giants of the sea, might have faced intense competition from these reptiles. Without the extinction of the plesiosaurs and mosasaurs, early cetaceans might have remained small and specialized, unable to grow into the massive creatures we know today. Dolphins and porpoises, too, might have evolved differently, perhaps remaining smaller and more elusive, avoiding the predatory reptiles that still ruled the oceans. The coral reefs, which are rich in biodiversity today, might have evolved in a more controlled manner, as the presence of large marine reptiles would have kept certain species of fish and invertebrates in check. The ecological balance of the oceans would have been different, with fewer opportunities for the explosive diversification of life that followed the extinction of these reptiles. This would have led to a more stable, but less diverse, marine ecosystem where the presence of large predators maintained a strict hierarchy among species. Moreover, the continuation of these ancient marine reptiles would have influenced human exploration and exploitation of the seas. In a world where the oceans are still patrolled by creatures as large and fearsome as mosasaurs, early human seafarers might have been more cautious, perhaps developing different methods of fishing and ocean travel to avoid encounters with these predators. The mythologies and legends of sea monsters might have been grounded in real encounters with these surviving reptiles, shaping human culture and history in unique ways. This alternate history paints a picture of an oceanic world where the survival of marine reptiles like plesiosaurs and mosasaurs kept the evolutionary path of the seas on a steady course, dominated by ancient predators. The impact of their continued presence would have rippled across the entire marine ecosystem, preventing the rise of new species and creating a world where the oceans remained a domain of giant, powerful reptiles, influencing everything from the evolution of marine life to the ways in which humans interacted with the sea. If large dinosaurs had remained at the top of the food chain, the structure of the food chain would have been vastly different from the one we know today. These dominant predators, such as Tyrannosaurus rex and other apex dinosaurs, would have continued to exert immense pressure on the ecosystems they inhabited, shaping the evolution of all other species beneath them. The presence of these giant carnivores would have dictated the survival strategies of herbivorous dinosaurs, forcing them to either evolve defensive traits like armored bodies or become faster and more elusive to avoid predation. This dynamic would have perpetuated a highly specialized and competitive environment where only the most well-adapted species could thrive. In this alternate world, the food chain would have remained heavily skewed towards these massive dinosaurs, with large herbivores like sauropods and hadrosaurs continuing to occupy the primary consumer roles. These herbivores would have consumed vast quantities of vegetation, maintaining a delicate balance within their ecosystems. The sheer size and number of these plant eaters would have required robust and diverse plant life to support them, leading to a landscape dominated by large, hardy plants that could withstand constant grazing and browsing. This would have created a feedback loop, where the availability of certain plants influenced the evolution of herbivores and in turn, the herbivores influenced which plants could thrive. Smaller creatures, such as early mammals, birds, and reptiles, would have been forced to adapt to a world where large dinosaurs controlled the primary food sources and habitats. These smaller animals would likely have remained on the fringes of the ecosystems, occupying niches that the dinosaurs did not dominate. This might have involved nocturnal behaviors, burrowing lifestyles, or a diet focused on insects, seeds, and other resources that the larger dinosaurs ignored. The continued dominance of dinosaurs would have restricted the opportunities for these smaller species to diversify and evolve into larger forms, keeping them relatively diminutive and specialized. In the oceans, if marine reptiles had also survived alongside their terrestrial counterparts, the marine food chain would have mirrored the structure seen on land. Large marine reptiles like plesiosaurs and mosasaurs would have continued to dominate, preying on fish, squid, and other marine animals. This would have limited the development of large marine mammals, like whales, and kept the oceans populated by creatures that could either evade or withstand the predation of these ancient reptiles. The top-down control exerted by these apex predators would have resulted in marine ecosystems that were less diverse but highly efficient, with fewer species occupying each trophic level compared to our current world. The overall structure of the food chain in this alternate scenario would have been one of immense creatures at the top, with smaller species adapting to the ecological spaces left by these giants. The presence of large dinosaurs would have maintained a hierarchy that left little room for the dramatic evolutionary shifts that occurred after their extinction. This would have kept Earth's ecosystems in a state of equilibrium that persisted for millions of years, with the same groups of animals dominating the planet in a relatively stable, albeit less diverse, world. The lack of significant evolutionary pressure from extinction events would have meant slower rates of change, with the food chain remaining a testament to the enduring power and influence of the dinosaurs. If mammals had remained small and nocturnal, never evolving into larger, more diverse species due to the continued presence of dinosaurs, the trajectory of life on Earth would have been profoundly altered. In this alternate scenario, the dominance of dinosaurs would have kept mammals in a state of perpetual adaptation to a world where their survival depended on avoiding the larger, more powerful reptiles. These small mammals, likely resembling modern-day shrews or rodents, would have continued to thrive in the shadows, leading lives focused on scavenging, foraging, and hunting at night when the dinosaurs were less active. The evolutionary pressures on these mammals would have driven them to become even more specialized in their nocturnal habits. Enhanced senses of hearing and smell would have been essential for navigating the dark and detecting both prey and predators. These mammals might have developed highly efficient metabolic systems to survive on limited food resources, and their reproductive strategies could have leaned heavily towards having large litters with shorter lifespans, ensuring the survival of their species despite the constant threat of predation. Without the opportunity to evolve into larger and more diverse forms, mammals would have remained confined to specific ecological niches. This would have severely limited their impact on the environment and the broader ecosystem. The lack of larger herbivorous mammals, for instance, would have left the plant life mostly under the influence of dinosaurs, preventing the evolution of grasslands and the ecosystems that rely on them. Forests and other dense habitats would have remained dominated by the towering dinosaurs, with mammals continuing to eke out an existence in the undergrowth. The absence of larger mammals would have also meant that certain evolutionary pathways were never explored. The evolution of intelligence, tool use, and complex social structures, all traits that eventually led to the rise of primates and humans, might never have occurred. In this world, the cognitive and social advances we associate with mammals, particularly primates, would be absent. Instead, any advancements in these areas would be left to the dinosaurs themselves if they ever developed them at all. The broader implications of this scenario extend to the entire planet's biosphere. Ecosystems would have remained relatively unchanged for millions of years, dominated by dinosaurs at every level. The resilience of these reptiles would have maintained a status quo that kept Earth's evolutionary clock ticking at a much slower pace. The dramatic shifts in climate and geography that occurred after the dinosaurs' extinction would have played out differently, with no mammals to take advantage of the new opportunities that arose. In a world where mammals never evolved beyond their small, nocturnal origins, the biodiversity we see today would be drastically different. The unique interplay between large mammals, their predators, and their environments, which has shaped so much of Earth's history, would be missing. Instead, the planet would be a place where dinosaurs continued to reign supreme, and mammals remained as background characters in a story dominated by the giants that never gave up their throne. This alternate history highlights just how crucial the rise of mammals was in shaping the world as we know it, and how different things could have been if the dinosaurs had never left the stage. If dinosaurs had continued to dominate the Earth, the development of early primates would have been significantly influenced by their presence, shaping an entirely different evolutionary path. In a world where large, powerful reptiles remained the dominant life forms, primates would have faced immense challenges in their quest for survival and adaptation. These early primates, which in our timeline evolved to become increasingly larger and more complex, might have remained small, agile, and arboreal, living in the safety of the treetops to avoid the dangers posed by the ground-dwelling dinosaurs. The need to stay out of reach of these large predators would have pushed primates to evolve heightened agility and dexterity, enabling them to navigate the forest canopy with ease. Their diet might have remained focused on fruits, insects, and other small, easily accessible food sources that could be found in the trees. The pressures of a world dominated by dinosaurs would have also driven the evolution of their sensory abilities. Acute vision, particularly the ability to see in low light, would have been advantageous for spotting predators and finding food in the dense, shadowy environments they inhabited. Social behaviors among early primates might have developed differently under the constant threat of dinosaurs. Living in close-knit groups would have provided safety in numbers, with intricate social structures evolving to ensure the protection of their young and the sharing of resources. Communication, both vocal and through gestures, could have become more sophisticated as a means of coordinating group movements and alerting others to danger. However, the constant need to remain hidden and avoid attention from large predators might have limited the development of loud or conspicuous social behaviors, keeping primates relatively quiet and secretive. The continued presence of dinosaurs would have restricted the habitats available to primates, likely confining them to specific regions where dense forests provided ample cover and food. This limitation in habitat range would have slowed their diversification into new species and restricted their ability to spread across different environments. Consequently, the evolutionary pathways that led to the development of larger brains and more complex problem-solving abilities might have been less pronounced, as the environmental pressures to adapt in these ways were lessened by the need to prioritize survival over exploration and innovation. In this alternate scenario, the rise of primates to the levels of complexity seen in our timeline would have been significantly delayed if it occurred at all. The dominance of dinosaurs would have created an ecological landscape where the opportunities for primates to evolve into more intelligent, tool-using species were minimal. The evolutionary trajectory that led to the emergence of hominins and eventually humans might never have happened. Instead, primates could have remained as relatively small, specialized creatures, expertly adapted to life in the trees, but without the potential to significantly alter their environments or create complex societies. This scenario highlights how the presence of dinosaurs could have fundamentally altered the course of primate evolution, keeping them in a state of perpetual adaptation to a world where survival depended on avoiding the giants that ruled the Earth. The eventual dominance of mammals, and particularly primates, in our timeline was facilitated by the extinction of the dinosaurs, allowing these small, adaptable creatures to explore new niches and evolve in ways that were impossible when the dinosaurs were at the top of the food chain. In a world where dinosaurs never left, the story of primates would have been one of survival, adaptation, and limitation, with the potential for intelligence and complex societies remaining just out of reach. If large herbivorous dinosaurs had continued to thrive, their feeding habits would have significantly influenced the patterns of plant growth and distribution across continents. These massive creatures, such as sauropods and hadrosaurs, would have shaped the landscape through their sheer size and dietary needs, leading to a world where vegetation evolved in response to the pressures of being constantly grazed and trampled by these giants. The presence of these large herbivores would have created distinct plant communities, with certain types of vegetation flourishing in areas frequented by dinosaurs. For instance, plants that could quickly regenerate after being eaten, or those that developed defensive adaptations like tough, spiky leaves would have become more common. In regions where these herbivores were particularly abundant, you might see vast expanses of hardy, fast-growing plants, creating ecosystems dominated by species that could withstand the constant browsing of these enormous animals. On the other hand, areas less populated by large dinosaurs might have seen different patterns of plant growth. Without the pressure of being continuously eaten, slower-growing plants, including more delicate or shade-tolerant species, could have thrived, leading to the development of lush, dense forests in some regions. The movement and migration of these herbivorous dinosaurs would have influenced which plants grew where, potentially creating a patchwork of different habitats across a single continent, each one shaped by the presence or absence of these creatures. The trampling effect of these large dinosaurs would have also played a role in shaping the terrain itself. In regions where sauropods roamed in large numbers, their heavy footfalls might have compacted the soil, preventing the growth of certain types of plants and promoting the spread of others that could tolerate such conditions. Over time, these trampling patterns could have led to the formation of vast grasslands or open savannas, where only the most resilient plants could take root and spread. In contrast, in regions where dinosaurs were less prevalent or where the terrain made it difficult for them to travel, you might find more diverse and complex plant communities. These areas could have developed into rich, biodiverse ecosystems with a wide variety of plants, from towering trees to delicate understory shrubs, all thriving in the absence of large herbivores. This variation in plant growth and distribution would have had a profound impact on the overall biodiversity of these regions, influencing not just the plants themselves, but also the animals that depended on them for food and shelter. The influence of large herbivorous dinosaurs on plant life would have extended beyond their immediate environment, potentially affecting global climate patterns as well. The types of plants that dominated certain regions would have influenced the amount of carbon dioxide absorbed from the atmosphere, potentially altering climate conditions on a continental or even global scale. The constant grazing by these dinosaurs might have kept certain areas open and grassy, reflecting more sunlight and contributing to different weather patterns compared to heavily forested regions. Overall, the continued presence of large herbivorous dinosaurs would have resulted in a world where the distribution of plants was closely linked to the movement and behavior of these massive animals. Their impact on the landscape would have been both direct, through their feeding and trampling, and indirect, by influencing the evolution of plants that had to adapt to survive in a world dominated by these giants. The result would have been a dynamic, ever-changing mosaic of ecosystems, each one shaped by the unique interactions between dinosaurs and the plants that sustained them. If large dinosaurs had continued to migrate and shape the landscape over millions of years, the Earth's geography would have evolved in ways distinctly different from what we know today. The sheer scale and constant movement of these creatures would have left a profound mark on the land, influencing everything from the formation of riverbeds to the spread of deserts and forests. Their migrations, often covering vast distances in search of food and water, would have carved out well-worn paths across continents, creating natural corridors that could eventually have evolved into major geographical features like valleys or even the early stages of river systems. As these enormous dinosaurs traveled in herds, their collective weight and movement would have compacted the soil beneath them, preventing the growth of certain types of vegetation and contributing to the creation of expansive grasslands and open savannas. Over millions of years, the repeated passage of these herds would have deepened these trails into natural routes that directed the flow of water during rains, potentially leading to the development of rivers and lakes. In some areas, where dinosaurs regularly congregated, the terrain might have been shaped into low-lying basins or depressions, which could become permanent water bodies, attracting even more wildlife and further altering the landscape. Conversely, in regions where these dinosaurs were absent or less frequent, forests might have remained dense and untouched, allowing for the formation of different types of ecosystems. The contrast between these open and forested areas would have created a diverse patchwork of landscapes, each shaped by the presence or absence of dinosaur activity. The constant grazing and trampling by herbivorous dinosaurs would have also played a role in preventing the spread of dense forests in certain areas, keeping these regions open and dominated by grasses and shrubs. The migration patterns of dinosaurs would have influenced the distribution of sediment and soil as well. In some regions, the constant movement of these massive creatures could have led to increased erosion, carrying soil and sediments away from certain areas and depositing them in others, potentially altering the course of rivers or the shape of coastlines. Over millions of years, these processes would have contributed to the creation of new landforms such as alluvial plains or deltas, where rivers emptied their sediment loads into the sea. The impact of these migrations would not have been limited to the land alone. Coastal regions, particularly those where dinosaurs might have gathered to drink or bathe, could have been shaped by their presence, with their movements influencing the erosion and deposition of coastal sands. This might have led to the creation of unique coastal features, such as large sandbanks or shallow bays, which could serve as crucial habitats for other forms of life. The continual reshaping of the landscape by these creatures would have also affected the climate in certain regions. Open grasslands, kept clear by the grazing dinosaurs, would reflect more sunlight than dense forests, potentially leading to localized changes in temperature and weather patterns. Over time, these changes could have had a broader impact on regional climates, perhaps even contributing to the development of distinct climatic zones shaped in part by the movements and activities of these ancient animals. In a world where large dinosaurs continued to roam and shape the landscape, the Earth's geography would have been a dynamic and ever-changing tapestry, with the marks of these creatures etched into the very structure of the planet. Their influence would have been felt in every corner of the world, from the formation of new rivers and valleys to the creation of vast grasslands and coastal features, all shaped by the relentless movement of these prehistoric giants. If dinosaurs had survived, their continued presence would have profoundly influenced the distribution and character of land-based ecosystems, leading to a world where rainforests, deserts, and plains adapted uniquely to accommodate these massive creatures. The existence of dinosaurs would have shaped the evolution of plant life and the very structure of these ecosystems, creating environments that catered to the needs of both herbivorous and carnivorous species. In rainforests, the towering size of some dinosaurs would have pushed trees to evolve even taller, creating dense, multi-layered canopies that provided food and shelter for various species. These rainforests would have been vibrant, with immense ferns, cycads, and towering conifers forming the backbone of the ecosystem. The movement of large herbivorous dinosaurs through these forests would have cleared paths and created open spaces, allowing sunlight to reach the forest floor and encouraging the growth of a diverse understory. These clearings might have served as crucial areas for other species, both plant and animal, to thrive, contributing to a dynamic and ever-changing rainforest landscape. In contrast, deserts would have evolved in response to the needs of dinosaurs capable of surviving in arid environments. The presence of large drought-resistant plant species, such as succulents and hardy shrubs, would have been common, offering sustenance to dinosaurs adapted to desert life. These dinosaurs might have played a role in spreading plant seeds across vast areas, ensuring the survival of vegetation in even the harshest conditions. The deserts themselves could have been more varied, with regions dominated by sand dunes interspersed with oases where dinosaurs gathered, their presence helping to sustain these vital water sources. The movement of dinosaurs through these regions could have influenced wind patterns and the distribution of sand, further shaping the desert landscape over time. Plains or vast open grasslands would have likely been some of the most extensively shaped ecosystems by the continued presence of dinosaurs. The constant grazing of large herbivores would have kept these areas open and free from encroaching forests, maintaining a landscape dominated by grasses and low-lying plants. These plains would have been expansive, stretching across continents, providing the perfect habitat for herds of dinosaurs to roam. The movement of these herds would have influenced the distribution of plant species, with grasses evolving to withstand the heavy grazing pressure. These ecosystems would have supported a diverse array of life, from smaller mammals and reptiles that scurried through the underbrush to predatory dinosaurs that stalked the plains, hunting the herbivores that grazed there. The interaction between these different ecosystems would have created transitional zones where the boundaries between rainforests, deserts, and plains were blurred. In these regions, the presence of dinosaurs would have been a key factor in determining the balance of vegetation and the types of animals that could thrive. These areas might have been rich in biodiversity, offering a mix of habitats where various species could coexist, each adapted to the unique challenges posed by the environment and the dinosaurs that shaped it. Overall, the survival of dinosaurs would have led to a planet where ecosystems were intricately linked to the behaviors and needs of these ancient creatures. Rainforests, deserts, and plains would have evolved in direct response to the presence of dinosaurs, resulting in a world where the landscape was a reflection of the dynamic relationship between these massive animals and the environment they helped to create. The Earth, in this scenario, would be a place where every ecosystem bore the mark of its ancient inhabitants, each one uniquely adapted to support life in a world still ruled by dinosaurs. If dinosaurs had continued to dominate the skies, the evolution of early birds would have taken a very different path. The presence of large, flying dinosaurs, such as pterosaurs, would have created significant competition for resources like food and nesting sites. In response, early birds would have had to find new ways to adapt and survive in a world where they were not the top aerial predators. To carve out their niche, these early birds might have evolved to become more specialized in certain aspects of flight and feeding. Instead of competing directly with large pterosaurs, they could have developed into smaller, more agile flyers, capable of navigating through dense forests and exploiting food sources that were inaccessible to their larger counterparts. This could have led to a greater diversification in beak shapes and sizes, allowing birds to feed on a variety of diets, from insects and seeds to nectar and small animals, depending on the available ecological niches. The need to avoid predation by flying dinosaurs might have also driven early birds to become more elusive and stealthy. Their plumage could have evolved to blend seamlessly with their environments, offering camouflage that helped them avoid detection from both aerial and ground-based predators. Additionally, birds might have developed more complex vocalizations, not only for communication within their species, but also as a way to warn each other of approaching danger. Nesting behaviors would have also evolved under the pressure of competition with dinosaurs. Early birds might have become more inventive in their nesting strategies, creating nests in hidden or hard-to-reach places such as cliff faces, dense foliage, or even burrows in the ground. These adaptations would have allowed them to raise their young in relative safety, away from the prying eyes of larger predators. In this scenario, the evolution of early birds would have been heavily influenced by the need to coexist with their dinosaur ancestors, leading to the development of a wide array of physical and behavioral traits designed to ensure their survival. Over time, these adaptations would have resulted in a diverse group of bird species, each perfectly suited to the unique challenges of their environment, yet all sharing the common thread of having evolved in the shadow of the dinosaurs that still ruled the skies. The skies in this alternate history would be a place of constant interaction and competition, with early birds finding their place among the ancient giants through innovation, adaptation, and a relentless drive to survive. If dinosaurs had survived, the predator-prey relationships that developed would have dramatically altered the evolution of other carnivores and herbivores, creating a world where the dynamics of the food chain were both complex and highly specialized. The continued presence of dominant predatory dinosaurs would have kept other carnivorous species in check, forcing them to adapt in ways that might have differed greatly from the evolutionary paths seen in our timeline. Smaller carnivores, unable to compete with the larger, more powerful dinosaurs, would have evolved to exploit different niches. These creatures might have developed into highly specialized hunters, focusing on prey that the larger dinosaurs ignored or could not easily access. This could have led to the evolution of more agile, stealthy predators that excelled in hunting smaller animals, insects, or even scavenging the leftovers from dinosaur kills. Over time, this specialization would have created a diverse array of carnivorous species, each adapted to a specific role within the ecosystem, but always remaining in the shadow of the dominant dinosaur predators. Herbivores, on the other hand, would have had to develop even more robust defenses to survive the constant threat posed by large predatory dinosaurs. These adaptations could have included thicker armor, enhanced speed, or more sophisticated herding behaviors to protect against attacks. In regions where predatory dinosaurs were particularly abundant, herbivores might have evolved to be more cautious and secretive, perhaps adopting nocturnal habits or retreating to more rugged, inaccessible terrain to avoid becoming easy targets. The survival of dinosaurs would also have influenced the size and social structures of herbivores. To counter the threat of predation, some herbivorous species might have evolved to become larger and more formidable, relying on sheer size and strength to deter predators. Others could have formed large, tightly knit herds, using numbers as a defense mechanism with complex communication systems to alert each other to danger. These changes would have led to the development of highly social, intelligent herbivores, capable of working together to protect their young and ensure the survival of the group. The impact of these altered predator-prey relationships would have extended beyond just the direct interactions between dinosaurs and other animals. The evolution of carnivores and herbivores in this world would have influenced the entire ecosystem, shaping the distribution of plants, the flow of energy through the food web, and even the physical geography of the land as species adapted to the presence of these formidable predators. For example, the constant grazing and movement of large herbivores could have led to the spread of certain types of vegetation, while areas frequented by large predators might have seen different patterns of plant growth due to the absence of certain herbivores. In a world where dinosaurs continued to dominate, the evolution of other species would have been a constant balancing act, with every adaptation driven by the need to survive in a landscape shaped by these ancient giants. The relationships between predators and prey would have been more intricate and layered, resulting in ecosystems that were both resilient and dynamic, with each species playing a crucial role in maintaining the balance of life. This alternate history would have given rise to a planet where the interactions between dinosaurs and other animals created a web of life that was as complex as it was fascinating, with evolution driven by the ever-present challenge of coexisting with Earth's most powerful creatures. If large predators like Tyrannosaurus rex had survived, their continued dominance would have significantly influenced the evolution of other apex predators, creating a world where competition at the top of the food chain was fierce and unrelenting. The presence of such formidable predators would have acted as a powerful selective force, driving other potential apex predators to adapt in ways that allowed them to coexist with or avoid direct competition from these giants. One possible outcome is that other large carnivores might have evolved to specialize in different types of prey or hunting strategies, allowing them to exploit niches that T-Rex did not dominate. For example, some predators could have become more adept at hunting in environments where T-Rex was less effective, such as dense forests or mountainous regions. These predators might have developed greater agility, sharper senses, or more sophisticated pack hunting tactics to take down prey that T-Rex could not easily reach. This specialization would have led to a diverse array of apex predators, each adapted to its unique environment and hunting style, but all shaped by the presence of T-Rex as the benchmark for power and strength. In contrast, some species might have evolved to become smaller and more elusive, avoiding direct confrontation with the towering T-Rex. These predators could have focused on scavenging or preying on smaller animals, carving out an ecological role that kept them out of the T-Rex's path. Over time, this could have led to the emergence of highly efficient, specialized carnivores that thrived in the shadows of the larger predator, contributing to a complex and layered predator hierarchy within ecosystems. The survival of T-Rex would have also impacted the evolution of herbivores, which in turn would influence the dynamics among other predators. Herbivores might have continued to evolve in ways that made them more challenging targets, whether through increased size, speed, or defensive capabilities like armored plates or advanced herding behaviors. This arms race between predators and prey would have kept the pressure on all carnivores to innovate and adapt, ensuring that only the most capable and adaptable predators could rise to or maintain their status at the top of the food chain. In this alternate scenario, the presence of T-Rex as a dominant apex predator would have led to a world where competition among top predators was intense, driving rapid and varied evolutionary changes. Ecosystems would have been characterized by a delicate balance of power, with different predators each mastering their niches, while constantly adapting to the challenges posed by their competitors. This dynamic would have resulted in a planet teeming with a rich diversity of predator species, all shaped by the towering presence of T-Rex as the ultimate test of survival in a world where only the strongest, smartest, and most adaptable could thrive. If competition with dinosaurs had driven mammals to evolve in entirely different niches, the evolutionary path of mammals would have been vastly different, leading to a world where mammals specialized in roles that avoided direct competition with their dinosaur counterparts. In this scenario, mammals might have remained small and nocturnal, continuing to adapt to environments and food sources that dinosaurs either overlooked or could not access. This could have resulted in mammals becoming highly specialized in areas such as burrowing, gliding, or even aquatic lifestyles, carving out ecological roles that allowed them to thrive in the shadows of the dominant dinosaurs. Mammals might have evolved to excel in niches where stealth, speed, and adaptability were key to survival. Instead of competing for large prey or open spaces dominated by dinosaurs, they could have focused on exploiting resources that were abundant but less desirable to the larger reptiles. This could have included insects, small vertebrates, and a variety of plants that were too difficult for dinosaurs to harvest effectively. Over time, this specialization would have led to the emergence of mammals with highly refined sensory abilities, such as echolocation in the case of insectivores, or specialized teeth and digestive systems for processing tough or toxic plants. In this alternate timeline, mammals could have also become masters of environments that were less accessible to dinosaurs. For instance, they might have developed the ability to live in extreme climates such as arid deserts, frigid tundras, or dense, tangled forests where dinosaurs were less dominant. These adaptations could have included features like thick fur, fat reserves, or even the ability to hibernate during harsh seasons, allowing mammals to exploit environments that were challenging but free from the heavy competition of dinosaurs. Another potential outcome is the evolution of mammals into creatures that relied on cooperative social structures to avoid predation and enhance their survival. Complex behaviors such as building intricate burrows, living in colonies, or developing sophisticated communication systems could have become the norm, enabling mammals to thrive in environments where dinosaurs were less of a threat. These social adaptations might have allowed mammals to occupy a variety of ecological niches while minimizing direct encounters with their more powerful reptilian competitors. Additionally, the evolution of mammals in response to dinosaur competition might have led to greater diversification in reproductive strategies. To ensure the survival of their young in a world filled with dinosaurs, mammals could have developed reproductive tactics such as producing fewer offspring but providing extensive parental care, or alternatively, having large litters with shorter gestation periods to increase the odds of survival. These strategies would have further refined mammals' ability to exploit niches where they faced less direct competition. In this world, the avoidance of direct competition with dinosaurs would have made mammals into a group of highly adaptable, resourceful creatures, thriving in the margins and niches left by the dominant reptiles. Their evolution would have been marked by an emphasis on flexibility, innovation, and specialization, resulting in a diverse array of species that were uniquely suited to their environments. As a result, the mammals that eventually emerged would be distinctly different from those in our timeline, with evolutionary traits shaped by the need to coexist with, rather than compete against, the giants of the Mesozoic era. If dinosaurs had continued to dominate the Earth, the evolution of reptiles like crocodiles and snakes would have been significantly shaped by their ongoing presence, leading to adaptations that allowed these reptiles to coexist with or avoid direct competition from the ruling dinosaurs. Crocodiles, already well adapted as ambush predators, might have evolved to become even more specialized in aquatic environments, where their stealth and power could be maximized without directly competing with larger land-based predators. These crocodiles could have developed greater size, or alternatively, more specialized forms, allowing them to exploit different aquatic niches such as deep rivers, coastal regions, or even the open ocean, where dinosaurs were less prevalent. In a world where dinosaurs continued to thrive, crocodiles might have also diversified in terms of diet and behavior. Some species could have evolved to hunt in packs, similar to modern-day wolves, to take down larger prey or defend territory from other aquatic predators. Alternatively, some crocodiles might have shifted towards a more scavenging lifestyle, taking advantage of the remains left by dinosaur predators, while others might have specialized in hunting smaller, more agile prey that dinosaurs overlooked. This diversification would have led to a wider range of crocodile species, each adapted to a particular ecological role within their aquatic habitats. Snakes, on the other hand, would have had to navigate a world where dinosaurs dominated the land, influencing their evolutionary trajectory towards more specialized and secretive forms. Their limbless bodies and ability to move silently through dense underbrush or burrows would have continued to evolve, making them some of the most efficient and elusive predators in environments where larger dinosaurs could not easily follow. This might have led to the development of snakes with more refined venom, allowing them to subdue prey quickly and safely, as well as enhanced camouflage and sensory capabilities to avoid detection by both prey and predators. The continued presence of dinosaurs would have also pressured snakes to diversify their diets and habitats. While some snakes might have evolved to become formidable constrictors, capable of taking down prey much larger than themselves, others might have specialized in consuming eggs, insects, or small mammals, allowing them to exploit ecological niches that were less competitive. Additionally, the need to avoid larger, more aggressive predators could have driven the evolution of arboreal snakes capable of living and hunting in the treetops, far from the reach of land-based dinosaurs. The evolutionary arms race between crocodiles, snakes, and dinosaurs would have likely resulted in a complex web of interactions, with each group adapting to the presence and behavior of the others. Crocodiles might have developed more robust armor or speed to protect themselves from dinosaur predators or to outcompete other aquatic reptiles, while snakes might have evolved more specialized hunting techniques and escape strategies to survive in a world where they were not the top predators. In this alternate timeline, the continued dominance of dinosaurs would have led to a world where reptiles like crocodiles and snakes became highly specialized survivors, each carving out a unique niche in ecosystems shaped by the presence of the giants. Their evolution would have been marked by innovation and adaptability, with every change driven by the need to coexist with the dinosaurs that still ruled the Earth. This would have resulted in a planet where the diversity of reptilian life was both extensive and finely tuned to the challenges of living alongside some of the most powerful creatures ever to walk the Earth. If dinosaur migration patterns had led to the development of isolated ecosystems similar to modern-day island biogeography, the Earth would have been home to a patchwork of unique environments, each evolving independently under the influence of the resident dinosaur populations. These isolated ecosystems could have formed in areas separated by natural barriers like mountain ranges, deserts, or vast stretches of water, where certain dinosaur species became confined to specific regions, unable to migrate further due to environmental constraints. In these isolated ecosystems, the evolution of both dinosaurs and other species would have taken a distinct and varied path, leading to a remarkable diversity of life forms, each adapted to the specific conditions of their environment. Much like the unique species found on islands today, such as the giant tortoises of the Galapagos or the lemurs of Madagascar, these isolated dinosaur populations might have developed unique physical traits, behaviors, and ecological roles that set them apart from their relatives in other regions. For instance, a group of herbivorous dinosaurs isolated in a region with limited resources might have evolved to become smaller, more efficient feeders, adapting to the scarcity of food by reducing their size and altering their feeding habits. On the other hand, in regions with abundant resources and few predators, dinosaurs might have grown larger and more specialized, developing traits that allowed them to dominate their local environment without the pressure of competition from other species. Predatory dinosaurs in these isolated ecosystems would have also evolved in response to the prey available in their specific regions. In some areas where large herbivores were scarce, predators might have become smaller and more agile, hunting in packs or focusing on smaller prey. In contrast, regions with abundant large herbivores might have given rise to even more massive and powerful predators, evolving to take down the giants of their isolated world. The isolation of these ecosystems would have also led to the evolution of entirely new species, as dinosaurs and other animals adapted to the unique conditions of their environment. Over time, these regions could have developed into biodiversity hotspots, much like the rainforests or coral reefs of today, where a wide variety of species evolved in response to the specific challenges and opportunities of their isolated habitats. The flora of these regions would have evolved in parallel, with plants adapting to the presence of the resident dinosaur populations. In areas with large grazing herbivores, plants might have evolved thicker bark, spines, or toxic chemicals to deter feeding, while in regions with less pressure from large herbivores, plants might have grown taller and more abundant, filling the landscape with dense forests or expansive plains. The overall impact of these isolated ecosystems would have been a planet where evolution took many different paths, resulting in a world teeming with unique and diverse species, each perfectly adapted to its own corner of the Earth. The concept of island biogeography, applied on a continental scale, would have led to the emergence of ecosystems as varied and distinct as the species that inhabited them, each shaped by the powerful influence of the dinosaurs that dominated their respective environments. This would have created a mosaic of life, where every isolated region told a different story of adaptation, survival, and the relentless march of evolution in a world still ruled by the giants of the past. If large dinosaurs had continued to contribute to the carbon cycle through their metabolic processes, the Earth's climate might have evolved differently, influenced by the unique role these massive creatures played in the ecosystem. The sheer size and number of these dinosaurs would have meant that their daily activities, eating, breathing, and most notably digesting, could have significantly impacted the carbon balance in the atmosphere. Dinosaurs, especially the large herbivores like sauropods, would have consumed vast amounts of vegetation, leading to a considerable intake of carbon stored in plants. Through their digestive processes, much of this carbon would have been released back into the atmosphere as methane, a potent greenhouse gas, and carbon dioxide. The collective contribution of millions of large dinosaurs producing methane could have resulted in a warmer, more humid climate, with higher levels of greenhouse gases than those seen in a world without these giants. This persistent input of methane into the atmosphere would have amplified the greenhouse effect, potentially leading to a planet with more extreme weather patterns. Global temperatures might have been consistently higher, creating a world where tropical climates extended further towards the poles and polar regions were less icy than they are today. Rainforests and other dense, warm ecosystems could have covered larger areas of the planet, while deserts might have been less extensive due to increased rainfall in regions that would otherwise be arid. The impact on plant life would have been equally profound. With higher temperatures and more carbon dioxide available for photosynthesis, plants might have grown more rapidly, with dense forests and sprawling grasslands dominating much of the landscape. These lush environments would have supported a vast array of life, but they also would have contributed to the cycle by sequestering carbon in their biomass, only for it to be released again as dinosaurs consumed them. Oceanic processes would have also been affected. Warmer temperatures could have led to changes in ocean currents and the distribution of marine life, with certain species thriving in warmer waters while others struggled to adapt. Coral reefs, often sensitive to temperature changes, might have developed differently, with potentially more extensive reef systems in warmer, nutrient-rich waters. Over millions of years, the ongoing influence of dinosaurs on the carbon cycle would have led to a dynamic equilibrium, where the carbon released by these creatures was balanced by the carbon absorbed by the rapidly growing vegetation. However, the overall climate would have remained warmer, wetter, and possibly more unstable, with the potential for more frequent and intense storms, higher sea levels, and less pronounced seasonal changes in many parts of the world. In this alternate timeline, the climate shaped by the continued presence of large dinosaurs would have created a planet that was both familiar and alien, with ecosystems and weather patterns fundamentally different from those we know today. The delicate balance between life and the environment would have been maintained, but with a distinctly Mesozoic flavor where the breath and digestion of dinosaurs played a crucial role in shaping the world around them. If the ongoing presence of dinosaurs had prevented the rise of large mammals like woolly mammoths and saber-toothed cats, the evolutionary landscape of Earth would have been markedly different. Without the extinction of dinosaurs, the opportunities for mammals to grow in size and diversify into the large, iconic species we know from the Ice Age would have been severely limited. The dominance of dinosaurs would have kept most mammals small, nocturnal, and specialized in niches that avoided direct competition with these powerful reptiles. In this scenario, the evolutionary path of mammals would have likely focused on survival strategies that allowed them to coexist with dinosaurs without challenging their dominance. Instead of evolving into large, cold-adapted species like the woolly mammoth, mammals might have remained predominantly small and agile, thriving in environments where dinosaurs were less prevalent, such as dense forests, underground burrows, or nocturnal habitats. These mammals would have been adept at avoiding predation, relying on speed, camouflage, and specialized diets to carve out a living in a world where dinosaurs ruled the larger landscapes. The absence of large mammals like saber-toothed cats would have also meant that certain ecological roles went unfilled or were taken up by different species entirely. Apex predation, which in our timeline saw the rise of powerful carnivores like the saber-toothed cats, might have been maintained by smaller, more pack-oriented predators that could take down prey through cooperation rather than sheer strength. Alternatively, some dinosaur species might have continued to evolve into specialized predators, maintaining their role as the top hunters in various ecosystems. Without large herbivores like mammoths, the landscape would have developed differently as well. the absence of these massive grazers would have influenced the spread of plant life, potentially leading to denser forests and less open grassland. The balance between plant growth and herbivory would have been maintained by smaller mammals and possibly smaller herbivorous dinosaurs that continued to feed on the vegetation. But the impact on the environment would have been less pronounced than that of massive herds of large mammals. The climate might also have been influenced by the absence of large mammals. The woolly mammoth, for instance, played a significant role in maintaining the grasslands of the Ice Age by trampling down trees and encouraging the spread of grasses. Without such activities, these grasslands might have remained more forested, which could have altered local climates by retaining more moisture and affecting temperature regulation. Additionally, the absence of large mammals would have meant fewer methane emissions from digestion, potentially influencing atmospheric conditions over time. In this alternate world, the Earth would have been shaped by a different balance of power in its ecosystems. Dinosaurs would have continued to be the dominant force, with mammals remaining in the background, adapting in ways that allowed them to survive without challenging the giants that still ruled the planet. The resulting ecosystems would have been rich in diversity, but lacking the dramatic shift toward large mammalian megafauna that characterized the Ice Age in our timeline. Instead, the Earth would be a place where small, resourceful mammals thrived alongside dinosaurs, creating a dynamic but fundamentally different natural world. If large dinosaur populations had continued to thrive, their activity would have subtly but meaningfully influenced the formation of the world's mountain ranges and other geological features over millions of years. While the tectonic forces responsible for creating mountains and shaping continents would still have been the dominant factors, the presence of large dinosaurs could have played a role in the erosion, sedimentation, and even the distribution of certain geological features. As these massive creatures roamed the land, their constant movement and feeding habits would have affected the landscape. The migration patterns of large herds, for instance, could have led to the creation of well-worn paths and plains, where the vegetation was trampled and soil was compacted. Over time, these routes could have influenced erosion patterns, with water following the paths of least resistance, carving out valleys and contributing to the shaping of river systems. In areas where these dinosaurs congregated, such as watering holes or seasonal feeding grounds, the concentrated activity might have accelerated soil erosion, leading to the formation of depressions or even basins that could eventually evolve into lakes or wetlands. In regions near tectonic plate boundaries where mountain ranges were forming, the presence of large dinosaurs could have influenced the distribution of sediments. The constant trampling and grazing by these creatures would have disrupted the soil, making it more susceptible to erosion. This loose sediment could then be transported by rivers and streams, contributing to the deposition of material in low-lying areas, potentially impacting the development of river deltas and alluvial plains at the base of these growing mountain ranges. Additionally, the weight and movement of large dinosaur populations could have contributed to the compaction of sediments in certain regions, particularly in coastal areas where dinosaurs might have congregated. This compaction could have had a long-term impact on sedimentary rock formation, influencing the types of rocks that developed in those regions and potentially affecting the way these rocks responded to tectonic forces over time. In areas where dinosaurs were less prevalent, such as high-altitude regions or more arid environments, the lack of significant animal activity might have allowed geological processes to proceed in a more undisturbed manner, leading to the development of different types of landscapes. Mountain ranges in these areas might have been less influenced by sedimentary processes tied to large animal populations and more shaped by wind erosion, glacial activity, and other natural forces. The long-term presence of dinosaurs could also have influenced the development of certain ecosystems associated with geological features. For example, the formation of mountain ranges often creates rain shadows, where one side of the range receives significantly less precipitation. In a world with large dinosaur populations, these rain shadow regions might have developed differently, with the types of vegetation and soil composition influenced by the activity of herbivorous dinosaurs. These creatures could have played a role in maintaining open grasslands or sparse forests in these areas, affecting the way these regions evolved over time. Overall, while the continued activity of large dinosaur populations wouldn't have directly caused the formation of mountain ranges or major geological features, their presence would have added another layer of complexity to the natural processes shaping the Earth's surface. Their influence on erosion, sedimentation, and landscape formation would have subtly guided the evolution of certain geological features, creating a world where the fingerprints of these ancient creatures were etched into the very rocks and soils that formed the planet's surface. If dinosaurs had survived and continued to dominate Earth's ecosystems, the evolutionary pressures on early hominids would have been profoundly different, potentially delaying or altering the course of human evolution. In a world where large, powerful dinosaurs remained the apex predators, early hominids would have faced a constant struggle for survival, requiring them to adapt in ways that were distinct from those seen in our actual history. The presence of these formidable predators would have forced early hominids to adopt more elusive and defensive survival strategies. Rather than evolving to become the dominant terrestrial species, early hominids might have remained smaller, more agile, and more arboreal, spending much of their time in trees or other elevated environments to avoid contact with the ground-dwelling dinosaurs. This lifestyle would have emphasized the development of traits such as enhanced grip strength, greater agility, and perhaps even a heightened sense of balance, allowing them to navigate treetops with ease. The need to avoid large predators would have also influenced hominid social structures and communication. Hominids might have evolved to live in smaller, more closely knit groups that relied on quiet, subtle forms of communication to coordinate their movements and alert each other to danger. Vocalizations could have remained more subdued, with body language and facial expressions playing a larger role in social interactions, reducing the risk of attracting unwanted attention from nearby predators. The competition for resources with both dinosaurs and other species would have likely pushed early hominids to diversify their diet and develop unique foraging strategies. Instead of focusing on large game, as later human ancestors did, hominids in this alternate scenario might have specialized in gathering fruits, nuts, insects, and small animals, exploiting ecological niches that were less contested by dinosaurs. This could have slowed the development of tool use, as the pressure to create weapons for hunting large prey would have been lessened, and tools might have remained simple and primarily geared towards foraging. The evolutionary pressures of living alongside dinosaurs could have also impacted the development of hominid intelligence and brain size. While the need for problem-solving skills and adaptability would have been crucial, the focus might have remained on survival tactics rather than innovation. This could have led to a slower pace of cognitive development, with technological advancements and complex social behaviors emerging later in hominid evolution. If dinosaurs had continued to thrive, the opportunities for hominids to expand into new territories and explore different environments would have been limited. The vast open plains that later hominids and early humans used to hunt and gather would have been dominated by dinosaurs, leaving hominids confined to more marginal, less hospitable regions. This confinement could have delayed the development of agriculture and the rise of early civilizations, as the large-scale cultivation of land would have been nearly impossible in a world where dinosaurs still roamed. In this alternate timeline, the course of human evolution might have been drastically altered, with hominids evolving into a species that was more specialized for survival in a world dominated by dinosaurs. The development of culture, technology, and complex societies could have been delayed by millions of years, or perhaps taken entirely different forms, shaped by the unique challenges of coexisting with Earth's ancient giants. This scenario paints a picture of a world where human evolution was not just a story of progress and innovation, but one of adaptation and resilience in the face of overwhelming odds. If large predatory dinosaurs had continued to roam the Earth, early human ancestors would have faced a drastically different set of challenges, leading to adaptations that might have steered human evolution down a unique path. In a world where these massive predators remained at the top of the food chain, early hominids would have needed to develop survival strategies that prioritized stealth, speed, and intelligence to avoid becoming prey. One of the most significant adaptations would likely have been an increased reliance on arboreal habitats. To stay safe from the ground-dwelling predators, early human ancestors might have spent much more time in trees, refining their climbing abilities and perhaps evolving more specialized hands and feet for gripping branches. This tree-dwelling lifestyle would have not only provided a refuge from predators, but also influenced social structures and daily routines, with hominids forming smaller, tightly knit groups that could move quickly and quietly through the forest canopy. The constant threat of predatory dinosaurs would have also driven the evolution of more acute senses. Early human ancestors might have developed sharper eyesight, better night vision, and heightened hearing to detect approaching predators from a distance. These enhanced senses would have been crucial for survival, allowing hominids to anticipate danger and take evasive action before it was too late. Communication among early hominids might have evolved to become more sophisticated and nuanced as well. In a world where loud noises could attract unwanted attention, hominids would have likely relied on a combination of subtle vocalizations, gestures, and body language to coordinate group movements and warn each other of impending threats. This could have laid the groundwork for the development of complex language, as the need for precise and efficient communication in a dangerous environment would have been paramount. Tool use would have been another critical adaptation, with early human ancestors possibly becoming highly skilled at creating and using tools for defense. Sharp sticks, stones, and other improvised weapons might have been used to fend off smaller predators or as deterrents against larger ones. Over time, the need to protect themselves from these formidable creatures could have spurred the development of more advanced tools and weapons, setting the stage for technological innovation earlier in human evolution. The pressure to avoid predation could have also led to more strategic use of the landscape. Early hominids might have become adept at utilizing natural features like caves, dense forests, and rocky outcrops as shelters and escape routes. This awareness of the environment, combined with an ability to navigate it quickly and effectively, would have been crucial for survival in a world where danger was ever present. Social cohesion and cooperative behaviors would have played a vital role in this dangerous world. Early human ancestors would have needed to work closely together to protect their young, share resources, and defend against predators. This reliance on group cooperation might have accelerated the development of social bonds, altruism, and eventually more complex societal structures. The evolutionary pressures of living alongside large predatory dinosaurs would have shaped early human ancestors into a species that was not only physically capable, but also highly intelligent, adaptable, and socially cohesive. Their survival would have depended on a delicate balance of avoiding danger, finding food, and maintaining group unity, leading to a unique blend of traits that would have distinguished them from other species in this alternate world. The result would have been a lineage of hominids finely tuned to thrive in a world where the giants of the past still walked the earth, setting the stage for a very different trajectory of human evolution. If large dinosaurs had continued to exist alongside early humans, their presence would have profoundly influenced the development of tools and weapons, shaping the trajectory of human technology and survival strategies. In a world where these massive creatures posed a constant threat, early humans would have been compelled to innovate more rapidly and effectively, creating tools and weapons specifically designed for both hunting smaller prey and defending against these formidable predators. The primary focus of early human toolmaking in this scenario would have been on developing weapons capable of inflicting serious damage or deterring large dinosaurs. Spearmaking, for instance, might have advanced quickly, with early humans crafting longer, sturdier spears tipped with sharpened stone or even bone. These spears could have been designed for throwing from a safe distance, allowing humans to strike at vulnerable parts of a dinosaur's body, such as the eyes or softer underbelly, without getting too close. The use of spear throwers, or atlatls, might have become widespread, enhancing the force and accuracy of these weapons. In addition to spears, early humans might have developed other projectile weapons to keep predators at bay. The bow and arrow could have evolved earlier, with arrows designed to penetrate thick hides or scales. The need for effective defense could have led to the use of poison-tipped arrows, utilizing natural toxins from plants or animals to increase the lethality of their weapons. Close combat weapons would have also been necessary for situations where early humans found themselves in immediate danger. Hand axes, clubs, and maces could have been common, with designs that maximized impact force and durability. These tools would have been essential not just for defense, but also for processing large kills, allowing humans to efficiently butcher prey for food while staying alert to potential threats. The presence of large dinosaurs would have likely spurred the development of fortified shelters and defensive structures. Early humans might have constructed more robust, enclosed living spaces using natural materials like stone, wood, and bone, creating barriers that could withstand the force of a charging dinosaur. These shelters would have been strategically placed in areas that offered natural protection, such as caves or cliffs, and could have included elevated platforms or watchtowers to keep an eye on approaching danger. Group hunting and defense would have become a cornerstone of early human society. The need to take down large prey or defend against predators would have required coordinated efforts, leading to the development of sophisticated communication and planning techniques. Early humans might have practiced ambush tactics, using their knowledge of the landscape and the behavior of dinosaurs to set traps or lures that could incapacitate or kill a large animal with minimal risk. The presence of dinosaurs would have also influenced the materials used in tool-making. Large bones, teeth, and hides could have been repurposed into weapons, armor, and tools. The bones of dinosaurs might have been carved into knives, scrapers, or even ceremonial objects, while their hides could have been used to make protective clothing or reinforced shelters. Over time, the continuous pressure to innovate in the face of such daunting predators would have accelerated the pace of technological development among early humans. The arms race between humans and dinosaurs would have driven the evolution of increasingly sophisticated tools and weapons, laying the groundwork for more advanced metallurgy and engineering techniques as humans sought to gain an edge over their massive competitors. In this alternate history, the presence of large dinosaurs would have made the development of early human tools and weapons a matter of survival, pushing early humans to become not just tool users, but expert weapon makers. This relentless drive to create effective hunting and defense strategies would have shaped the course of human evolution, leading to a culture deeply rooted in innovation, cooperation, and the mastery of the environment in a world still dominated by the giants of the past. If dinosaurs still dominated large parts of the globe, early human migration patterns would have been vastly different, dictated by the need to avoid regions where these giant reptiles were most prevalent. Instead of expanding rapidly across continents, early humans would have likely followed more cautious and circuitous routes, steering clear of territories controlled by large predators. These dinosaurs would have acted as formidable barriers, shaping the direction and speed of human dispersal across the planet. In this alternate scenario, early humans might have initially concentrated in areas where dinosaurs were less abundant or where natural barriers such as mountains, rivers, or dense forests offered protection. These safe havens would have become the cradles of early human societies, fostering the development of complex cultures and technologies in regions where the threat of predation was minimal. Coastal areas, highlands, and isolated valleys could have served as key corridors for migration, allowing early humans to gradually expand their range without directly confronting the dominant dinosaur populations. As humans developed more advanced tools and strategies for survival, they might have ventured into territories previously dominated by dinosaurs, but this expansion would have been slow and deliberate. The presence of these powerful creatures would have forced humans to adapt their migration strategies, possibly leading to the establishment of seasonal patterns where certain areas were only occupied during times when dinosaurs were less active or when environmental conditions provided a temporary advantage. The migration routes that early humans took would have also been influenced by the availability of resources. Regions rich in food, water, and shelter, but relatively free of dinosaurs, would have been highly sought after, creating competition among human groups for access to these prime territories. This competition could have driven early human societies to innovate more rapidly, developing new tools, weapons, and social structures to secure and defend these valuable resources. In contrast, vast swathes of land dominated by large dinosaurs might have remained largely uninhabited by humans, creating pockets of untouched wilderness where these ancient creatures continued to thrive. These dinosaur-dominated regions would have served as natural boundaries between human populations, potentially leading to greater cultural and genetic diversity as isolated groups evolved separately, adapting to their unique environments. The pressure to avoid dinosaurs would have also influenced the timing of migrations. Rather than moving into new areas at random, early humans might have carefully timed their movements to coincide with environmental changes such as seasonal shifts or climatic events that temporarily reduced the dinosaur population or made certain areas more accessible. These migrations would have been marked by careful planning and reconnaissance, with scouts and hunters playing crucial roles in determining the safety of new territories. The interaction between humans and dinosaurs during these migrations would have led to a unique dynamic where humans constantly adapted their strategies to avoid direct confrontation while still seeking out new lands to settle. This delicate balance between exploration and caution would have defined the spread of humanity across the globe, resulting in a world where human expansion was slower and more fragmented, but also deeply informed by the presence of these ancient giants. Over time, the need to navigate a world shared with dinosaurs would have shaped not only the physical migration patterns of early humans, but also their cultural and technological development. Societies that successfully learned to coexist with or avoid these predators would have thrived, leading to the rise of complex civilizations in regions where humans could establish themselves securely. The story of early human migration in this alternate history would be one of ingenuity, resilience, and a constant dance with the powerful creatures that once ruled the earth. If early human settlements had to be built to withstand attacks from large dinosaurs, the architecture and layout of these communities would have been fundamentally different from what we imagine today. The constant threat of such massive predators would have driven early humans to prioritize defense and fortification in ways that would have shaped their societies, technologies, and daily lives. Settlements would have been strategically located in areas offering natural protection, such as cliffs, high plateaus, or densely forested regions where large dinosaurs would find it difficult to navigate. These locations would not only provide a natural barrier against attacks, but also limit the directions from which predators could approach, making it easier to defend the community. In areas without natural defenses, early humans would have constructed their own, building walls from massive stone blocks, timber, or even mud bricks, reinforced with bones or other materials to withstand the immense force of a dinosaur's attack. The design of these settlements would have been heavily influenced by the need for security. Buildings might have been constructed with low profiles, blending into the landscape to avoid attracting attention, or raised on stilts or platforms to keep inhabitants out of reach of ground-based predators. Entrances would have been narrow and easily barricaded, with multiple layers of doors or gates to prevent breaches. Homes and communal structures would have likely been clustered together in tight formations, minimizing the perimeter that needed to be defended and creating a sense of collective security. Watchtowers and lookout posts would have been essential features, allowing sentries to keep a constant vigil for approaching threats. These towers might have been equipped with early warning systems such as drums, horns, or signal fires to alert the entire settlement of an impending attack. Defensive weapons, including spears, slings, and eventually more advanced projectiles, would have been stockpiled and kept within easy reach, ready to be used at a moment's notice. The need for robust defenses would have also driven technological innovation. Early humans might have developed more advanced construction techniques, learning to quarry and shape large stones or create composite materials that could better withstand the physical force of a dinosaur. Engineering would have become a key skill, with knowledge passed down through generations on how to build structures capable of enduring the unpredictable threats posed by these massive creatures. The daily routines of these communities would have been structured around safety protocols. People would likely move in groups when venturing outside the settlement, with scouts and hunters constantly on the lookout for signs of nearby dinosaurs. Agriculture would have been practiced within fortified fields or in areas where natural barriers provided protection, and livestock would have been kept in secure enclosures, possibly underground or within the walls of the settlement itself, to prevent them from being an easy target for predators. Cultural practices and rituals might have developed around the need for protection and defense. The construction of a new settlement could have been accompanied by ceremonies invoking the favor of deities or spirits believed to protect against dinosaurs. The stories and myths of these societies would have been filled with tales of bravery and cunning, celebrating the heroes who defended their communities from the colossal beasts that roamed the land. In this alternate history, the presence of large dinosaurs would have shaped not only the physical aspects of human settlements, but also the social structures, technologies, and cultural identities of the people living within them. These communities would have been marked by their resilience and ingenuity, developing complex strategies and technologies to ensure their survival in a world where the threat of a dinosaur attack was ever present. The need to coexist with such powerful creatures would have left an indelible mark on the evolution of human civilization, influencing everything from architecture to social organization in ways that would have defined their existence for generations. If dinosaurs had competed with humans for land and resources, the development of agriculture would have been shaped by the need to secure food supplies in the face of formidable competition. Early humans would have had to devise innovative strategies to cultivate crops and protect their harvests from these massive creatures, leading to agricultural practices that were both defensive and resourceful. In regions where large herbivorous dinosaurs roamed, humans would have needed to protect their crops from being trampled or eaten. This would have led to the construction of fortified fields, surrounded by strong barriers such as stone walls, deep trenches, or dense hedgerows designed to keep dinosaurs out. These fortifications would have required significant labor and engineering knowledge, making agricultural fields more akin to small fortresses than the open expanses we typically associate with farming. Crop selection would have been influenced by the need to grow plants that were either less appealing to dinosaurs or could thrive in more protected environments. Humans might have focused on cultivating hardier, faster-growing crops that could withstand some level of disturbance or that matured quickly, allowing for multiple harvests in a season to mitigate losses. Alternatively, certain crops might have been developed to grow in vertical gardens or on raised platforms out of reach of ground-based dinosaurs. Livestock farming would have also been significantly impacted. Domesticated animals would need to be kept in secure enclosures, potentially underground or within the walls of human settlements, to protect them from predatory dinosaurs. This could have led to the development of more intensive forms of animal husbandry, where animals were kept closer to human habitation and fed with stored fodder rather than grazing freely. The close proximity of livestock might have influenced the evolution of human diets, with an increased reliance on dairy products, eggs, and other easily secured animal resources. The constant threat of dinosaurs encroaching on agricultural land would have driven humans to explore new farming techniques that could maximize yield while minimizing risk. Crop rotation, intercropping, and companion planting might have been developed earlier, as these methods would not only improve soil fertility but also make it harder for dinosaurs to decimate entire fields. Additionally, the cultivation of plants with natural deterrents, such as strong odors or bitter tastes, could have been prioritized to discourage dinosaurs from feeding on human crops. Water management would have become crucial in regions where dinosaurs competed for access to rivers and lakes. Humans would have had to develop sophisticated irrigation systems to ensure their crops received sufficient water without relying on sources that were also frequented by dinosaurs. This could have led to the construction of aqueducts, canals, and reservoirs, enabling agriculture to flourish even in areas where direct access to water was contested. The competition with dinosaurs would have also influenced the social and economic structures of early agricultural societies. Communities might have formed alliances to share resources and protect their lands from dinosaur incursions, leading to the early development of cooperative farming practices and collective defense strategies. Trade networks would have likely expanded as well, with communities exchanging surplus crops and livestock for materials and tools that could help them fortify their fields and settlements. Over time, the challenges posed by dinosaurs would have driven humans to innovate in ways that fundamentally shaped the course of agricultural development. The need to protect crops and livestock from these ancient competitors would have led to the early adoption of technologies and farming techniques that emphasized efficiency, security, and resilience. In this alternate history, human agriculture would have been characterized by a blend of ingenuity and adaptability, with every harvest representing not just a triumph over nature, but a victory in the ongoing struggle to coexist with the giants of the past. If dinosaurs had coexisted with humans, their presence would have undoubtedly left a deep imprint on human religious beliefs and mythologies, shaping the cultural development of societies across the globe. These enormous, powerful creatures would have been seen as living embodiments of natural forces, likely revered or feared as manifestations of the divine or the demonic. The stories and legends that arose around these beings would have formed the backbone of religious practices, influencing everything from the way communities worshipped to the values they held dear. In this alternate history, dinosaurs might have been worshipped as gods or sacred animals, with different species representing various aspects of the natural world. A towering, long-necked sauropod could be seen as a symbol of life-giving rain and fertility, while a fierce predator like Tyrannosaurus rex might embody the destructive power of storms or war. Temples and shrines dedicated to these dinosaur deities could have been built, where priests and shamans offered sacrifices or conducted rituals to appease or seek favor from these mighty beings. The mythology surrounding dinosaurs would likely include tales of creation and destruction, with these creatures playing central roles in the origin stories of various cultures. Some societies might believe that the world was created by the first dinosaur, whose body became the land, rivers, and mountains. Others could have legends of a great battle between dinosaurs and ancient heroes, representing the struggle between order and chaos, or the cyclical nature of life and death. Religious festivals and ceremonies could have been timed to coincide with the seasonal migrations or behaviors of local dinosaur populations. For example, a culture might celebrate the arrival of a particular species of dinosaur as a sign of the coming rainy season, with rituals designed to ensure a bountiful harvest. Conversely, the departure or hibernation of dinosaurs might be marked by mourning or preparation for a harsh winter, with rituals aimed at protecting the community during the difficult times ahead. The presence of dinosaurs would have also influenced the moral and ethical teachings of these religions. The power and majesty of these creatures might have been used to teach lessons about respect for nature, the importance of balance and harmony, or the dangers of hubris. Myths about individuals who disrespected or underestimated the dinosaurs could serve as cautionary tales, warning against arrogance and promoting humility in the face of the natural world. The social structures of these cultures would have been deeply intertwined with their religious beliefs. Leaders might have claimed a divine right by associating themselves with a particular dinosaur or by performing rituals that demonstrated their connection to these sacred creatures. Shamans or priests who could communicate with or control dinosaurs might have held significant power, guiding the spiritual and political direction of their communities. Art, music, and literature in these societies would have been rich with dinosaur imagery, reflecting their central place in the cultural imagination. Paintings, sculptures, and carvings depicting these creatures would have adorned temples, homes, and public spaces, while songs and stories about their deeds and characteristics would have been passed down through generations. Even language itself might have evolved to include terms and phrases inspired by the presence of dinosaurs, influencing the way people thought and talked about the world around them. In this world, where human religious beliefs and mythologies were shaped by the presence of dinosaurs, cultures would have developed in ways that reflected a deep connection to these ancient creatures. The reverence and fear that dinosaurs inspired would have permeated every aspect of life, creating societies that were both awed by and attuned to the powerful forces of nature embodied by these living giants. The legacy of these beliefs would have endured long after the dinosaurs themselves, continuing to influence human culture in profound and lasting ways. If dinosaurs had been the primary source of food and materials for early humans, hunting practices would have evolved into a complex and highly specialized activity, deeply embedded in the daily life and culture of human societies. The sheer size and power of dinosaurs would have required early humans to develop sophisticated techniques, tools, and strategies to successfully hunt these massive creatures, shaping not only their survival, but also their social structures and technological advancements. To hunt dinosaurs effectively, early humans would have needed to work together in well-coordinated groups, using teamwork and strategy to bring down prey that far outmatched them in size and strength. This reliance on collective effort would have fostered strong social bonds and a sense of community, as successful hunts depended on the cooperation and trust of all involved. Over time, hunting dinosaurs could have become a central aspect of human society, with rituals, traditions, and hierarchies built around the hunt. The tools and weapons used for hunting would have been highly specialized, designed to maximize effectiveness against different types of dinosaurs. Spear throwers, bows, and eventually more advanced projectiles like javelins or even early siege weapons could have been developed to target vulnerable areas of a dinosaur's body, such as the eyes, throat, or joints. The need for powerful, durable weapons would have driven innovation in materials and craftsmanship, leading to advancements in metallurgy and engineering that were directly tied to the demands of dinosaur hunting. The knowledge required to hunt dinosaurs would have been extensive, passed down through generations and refined over time. Hunters would have needed to understand the behavior, migratory patterns, and vulnerabilities of different dinosaur species, developing tactics that took advantage of specific environmental conditions or seasons. This deep understanding of their prey would have made hunters some of the most respected and knowledgeable members of their communities, with their skills and wisdom considered essential for the survival of the group. The risks associated with hunting dinosaurs would have been significant, leading to the development of protective measures and safety protocols. Early humans might have constructed elaborate hunting traps or used the landscape to their advantage, driving dinosaurs into natural enclosures or over cliffs to reduce the danger of direct confrontation. These strategies would have required careful planning and coordination, turning hunting into a highly organized and ceremonial activity. The materials obtained from dinosaurs would have been invaluable, with every part of the animal used to meet the needs of the community. Meat would have been a crucial source of food, likely preserved through drying, smoking, or salting to ensure a steady supply during lean times. Dinosaur hides could have been used for clothing, shelter, and even armor, while bones, teeth, and claws would have been crafted into tools, weapons, and decorative items. The sheer abundance and utility of these materials would have made dinosaurs a central resource in the economy and daily life of early human societies. Over time, the reliance on dinosaurs for food and materials would have influenced the development of trade networks, as different regions specialized in hunting specific species or crafting particular goods. These trade routes would have facilitated the exchange of not only resources, but also knowledge and culture, spreading innovations in hunting techniques, toolmaking, and social organization across vast distances. The cultural significance of dinosaur hunting would have been immense, shaping the mythology, art, and identity of human societies. Stories of great hunts and legendary hunters would have been told and retold, becoming part of the oral traditions and eventually the written records of these cultures. Dinosaur motifs could have been common in art and symbolism, representing strength, endurance, and the mastery of nature. In this alternate history, the evolution of human hunting practices, driven by the need to hunt and utilize dinosaurs, would have left a lasting impact on the development of human civilization. The challenges and opportunities presented by these massive creatures would have pushed early humans to innovate, cooperate, and adapt in ways that defined their culture, technology, and society for generations to come. If the domestication of animals had been influenced by the need to protect livestock from predatory dinosaurs, the process would have taken a different path, leading to the development of animals specifically bred for defense and vigilance. Early humans, facing the constant threat of large predatory dinosaurs, would have selected and bred animals not just for their utility as food or labor, but also for their ability to safeguard other valuable livestock. Guard animals, such as dogs, would have played an even more crucial role in early human societies. These animals would have been bred for size, strength, and aggressiveness to confront or deter dinosaurs that threatened herds of livestock. Over generations, the most effective guard animals would have been those that could work in packs, coordinating their efforts to harass or drive away predators. The bond between humans and these protective animals would have been strong, as the survival of livestock, and by extension, the community, depended on their vigilance and courage. In addition to guard animals, humans might have domesticated and bred animals that could serve as early warning systems. Birds with keen senses of sight and hearing, such as certain species of raptors, could have been trained to alert humans to the presence of dinosaurs long before they became a direct threat. The domestication of such animals would have been focused on enhancing their natural abilities to detect and signal danger, making them indispensable members of human settlements. The physical layout and organization of farms and pastures would have also been influenced by the need for protection. Livestock enclosures would have been designed with both defense and observation in mind, incorporating elevated platforms, sturdy fences, and strategically placed guard posts where domesticated animals could keep watch. These enclosures might have been fortified with natural barriers like thorny bushes or steep terrain to make it harder for dinosaurs to approach undetected. Domesticated herd animals themselves could have been bred for behaviors that made them less vulnerable to predation. Animals that exhibited strong flocking or herding instincts, staying close together for mutual protection, would have been favored. Additionally, livestock with greater endurance and speed could have been selectively bred to escape from predators more effectively, leading to the development of faster, more agile animals that could outmaneuver or outrun threats. The necessity of protecting livestock from dinosaurs would have also driven innovations in animal husbandry. Techniques such as rotational grazing, where livestock are moved between different pastures to avoid attracting predators to a single location, could have been developed earlier. This practice would have reduced the risk of any one area becoming a hunting ground for dinosaurs, helping to keep livestock safe and ensuring sustainable land use. In terms of cultural impact, the relationship between humans and their protective animals would have been deeply embedded in the society's identity and mythology. Stories and traditions celebrating the bravery of guard animals or the cleverness of early warning birds would have been passed down through generations, reinforcing the importance of these animals in the survival and success of the community. Rituals and ceremonies might have been held to honor these animals, recognizing their critical role in protecting the herds and, by extension, the people who relied on them. Over time, the need to protect livestock from predatory dinosaurs would have led to a unique form of domestication, where animals were valued not just for their practical uses, but for their ability to contribute to the safety and security of the community. This specialized approach to domestication would have shaped human societies in profound ways, influencing everything from agricultural practices to social organization, and leaving a lasting legacy in the cultures that evolved under the constant shadow of these ancient predators. If dinosaurs had created natural barriers or dangers for early civilizations, the development of trade routes and exploration would have been significantly influenced by the need to navigate around or through territories dominated by these massive creatures. Early human societies would have had to carefully plan their movements, taking into account the presence of dinosaurs that could easily disrupt or endanger trade caravans and explorers. Trade routes would likely have been established along paths that avoided the habitats of the most dangerous dinosaurs. This would have led to the creation of longer, more circuitous routes that skirted the edges of dinosaur-dominated regions, rather than taking the shortest or most direct paths. These safer, indirect routes might have followed natural barriers like rivers, mountain ranges, or coastlines, where the terrain offered some protection from the dangers posed by roaming dinosaurs. In areas where avoiding dinosaurs was impossible, early civilizations would have developed strategies to minimize the risks. Caravans traveling through dangerous regions might have been heavily armed, with guards and hunters trained to fend off potential attacks. They could have also traveled during specific times of the day when dinosaurs were less active, such as dawn or dusk, to reduce the likelihood of encounters. Additionally, the construction of fortified rest stops or way stations along trade routes would have been essential, providing safe havens for travelers to regroup and resupply while staying protected from the dangers outside. The presence of dinosaurs as natural barriers would have also influenced the locations of early settlements and cities. Civilizations might have been founded in areas that were naturally protected from dinosaur incursions, such as on islands, peninsulas, or high plateaus. These locations would have become hubs of trade and exploration, with networks of routes radiating outwards that carefully navigated the surrounding dangers. Cities situated near these natural barriers would have been vital centers of commerce, controlling the flow of goods and information between regions separated by dinosaur-infested lands. Exploration would have been a more cautious and calculated endeavor, driven by the need to discover safe passages through or around these dangerous territories. Explorers would have been seen as daring pioneers, mapping out routes that avoided the most hazardous areas while seeking new opportunities for trade and expansion. The exploration of regions heavily populated by dinosaurs would have been slow, as the risks involved would have necessitated thorough planning and preparation. Over time, explorers might have developed specialized knowledge and tools for dealing with dinosaurs, such as deterrents, traps, or decoys, allowing them to venture deeper into uncharted lands. The impact of dinosaurs on trade and exploration would have also shaped the relationships between different civilizations. Regions that were able to control safe passages through dinosaur territory would have gained significant economic and political power, becoming gatekeepers for the flow of goods and resources. Alliances and conflicts might have arisen over control of these critical trade routes, with civilizations vying for dominance over the safest and most profitable paths. Culturally, the presence of dinosaurs as obstacles to trade and exploration would have left a lasting mark on the societies of the time. Myths and legends about brave traders, explorers, and heroes who faced down or outwitted dinosaurs would have become central to the storytelling traditions of these cultures. These tales would have reinforced the importance of ingenuity, bravery, and resilience in the face of overwhelming natural challenges. In this alternate history, the development of trade routes and exploration would have been a testament to human adaptability and perseverance. The presence of dinosaurs as both natural barriers and dangers would have forced early civilizations to innovate and collaborate in ways that shaped their growth and interactions. The complex web of trade routes that eventually emerged would have reflected a world where the challenges posed by nature were met with determination and resourcefulness, leading to a rich and interconnected global tapestry of human culture and commerce. If the ongoing presence of dinosaurs had influenced the development of human medicine, the field would have evolved in a unique direction, with remedies and treatments deeply rooted in the biology of these ancient creatures. The immense variety of dinosaurs, each with distinct physiological traits, would have provided early humans with a vast resource for medical exploration, leading to the discovery of new healing substances, techniques, and practices. In this alternate history, healers and early scientists would have focused on studying the properties of dinosaur tissues, bones, and secretions, seeking to unlock their potential for treating human ailments. The thick, durable skin of some dinosaurs might have been processed into protective bandages or wound dressings, prized for their ability to prevent infection and promote healing. Similarly, the powerful bones of these creatures could have been ground into powders or used in medicinal broths believed to strengthen the human body or accelerate the healing of fractures. Dinosaur blood, with its unique chemical composition, might have been harvested for its potential healing properties. Perhaps certain species of dinosaurs possessed natural anticoagulants or agents that promoted blood clotting, which early medical practitioners could have extracted and applied to human injuries. Over time, this practice might have evolved into more advanced forms of blood therapy, where compounds derived from dinosaurs were used to treat a range of conditions, from wounds to chronic illnesses. The organs and glands of dinosaurs could have been another focus of medical research, with early humans discovering that certain glands produced substances with potent medicinal effects. For example, the liver or pancreas of a dinosaur might have contained enzymes or hormones that were harnessed to treat digestive disorders or metabolic conditions in humans. These discoveries would have led to a deep understanding of the internal chemistry of dinosaurs and how it could be applied to human health. Herbal medicine, already a cornerstone of early human healthcare, would have been complemented by remedies derived from dinosaurs. The study of plants and dinosaurs together might have revealed symbiotic relationships where certain plants only thrived in the presence of particular dinosaurs, leading healers to combine these plant-based remedies with dinosaur-derived substances for enhanced effects. This combination of botanical and zoological medicine would have created a rich, integrated approach to healing, where the natural world was seen as a unified source of cures. The use of dinosaur venom or toxins could have also played a role in developing medicines and antidotes. If certain dinosaurs possessed venomous bites or toxic secretions, early humans might have learned to extract and dilute these substances, using them to treat conditions ranging from infections to chronic pain. This would have required careful experimentation and deep knowledge of both the dangers and benefits of dinosaur-derived substances, leading to the early development of pharmacology as a discipline. The influence of dinosaurs on medicine would have extended beyond just physical treatments. The bones and fossils of these creatures might have been used in ritualistic or spiritual healing practices, believed to carry the power of the ancient world. Shamans and healers could have incorporated dinosaur remains into their rituals, using them to connect patients with the strength and vitality of these powerful beings, blending physical and spiritual healing in a way that deeply resonated with their culture. Over time, the study and use of dinosaur biology in medicine would have led to a sophisticated understanding of how these creatures could contribute to human health. Medical knowledge would have expanded, not just through the empirical study of dinosaur biology, but also through the cultural exchange of remedies and treatments across different regions and civilizations. This would have created a diverse and evolving medical tradition where the legacy of dinosaurs lived on in the healing practices of humanity. In this world, the ongoing presence of dinosaurs would have made them integral to the development of human medicine, shaping the way societies understood and approached health and healing. The integration of dinosaur biology into medical practices would have been a testament to human ingenuity and adaptability, reflecting a deep connection with the natural world and the ancient creatures that shared the earth. If humans had to coexist with large dinosaurs, the development of cities and infrastructure would have taken a very different path, shaped by the need to protect communities and resources from these enormous creatures. Cities would have been designed with fortification as a primary concern, resulting in layouts and construction methods that emphasized defense durability, and strategic planning to minimize the risks posed by dinosaurs. Urban centers would likely have been located in areas that offered natural protection, such as on high plateaus, surrounded by rivers, or within mountain valleys where the terrain itself could help deter or slow down large dinosaurs. These locations would have been carefully chosen to reduce the likelihood of dinosaur incursions, with city planners prioritizing safety over convenience. The boundaries of cities might have been marked by massive walls or earthworks constructed from materials like stone, brick, or even reinforced wood to withstand the sheer force of a dinosaur's impact. The design of buildings within these cities would have reflected the constant threat posed by dinosaurs. Structures would have been built with strong foundations and thick walls, using materials that could resist damage from a collision with a large animal. Roofs might have been sloped or reinforced to prevent collapse in the event of a dinosaur walking over them or brushing against them. Buildings could have been clustered closely together, creating narrow streets that would be difficult for dinosaurs to navigate, effectively limiting their movement within urban areas. Infrastructure like roads, bridges, and water systems would have been designed with an eye towards both functionality and defense. Roads might have been elevated or constructed with barriers along their edges to prevent dinosaurs from easily accessing them, while bridges would have been built with the capability to withstand the weight of a dinosaur crossing or to be quickly dismantled in case of an emergency. Water supplies would have been protected by underground aqueducts or enclosed reservoirs, ensuring that vital resources were not easily disrupted by the presence of dinosaurs. Public spaces within cities, such as markets, plazas, and gardens, would have been designed with safety in mind. Large open areas might have been surrounded by defensive structures or enclosed with walls, allowing people to gather without fear of a sudden dinosaur intrusion. These spaces could have also included lookout towers or elevated platforms where sentries could keep watch for approaching threats, providing an early warning system for the city's inhabitants. The presence of dinosaurs would have also influenced transportation networks. Long-distance travel between cities might have been conducted through well-protected roads or even tunnels, designed to keep travelers safe from roaming dinosaurs. In some regions, river or sea routes could have been preferred for trade and communication, as these would offer a safer alternative to land travel through dangerous territories. Over time, the need for secure transportation might have led to the development of more advanced engineering techniques, including the construction of fortified highways, bridges with retractable sections, or even early forms of railways that could move people and goods quickly while minimizing exposure to dinosaurs. City planning would have also included considerations for agriculture and resource management. Farmland would likely have been located within the protective boundaries of the city or in fortified outlying areas where crops and livestock could be monitored and defended. This could have led to the development of vertical farming or other intensive agricultural practices that maximized output within limited, secure spaces. Storage facilities for grain, water, and other essentials would have been heavily protected, ensuring that communities could survive prolonged periods of isolation in the event of a dinosaur threat. Overall, the coexistence with large dinosaurs would have driven humans to develop cities that were as much fortresses as they were centers of culture and commerce. The need to balance safety with the demands of urban life would have led to innovations in architecture, engineering, and city planning that reflected the unique challenges of sharing the world with these ancient giants. In this alternate history, human civilization would have evolved with a deep awareness of the power of nature, creating urban landscapes that were both resilient and adaptable, designed to thrive in a world where dinosaurs still roamed the earth. If the construction of ancient wonders like the pyramids or the Great Wall of China had been influenced by the need to keep dinosaurs at bay, these monumental structures would have taken on even greater significance as both symbols of human ingenuity and as essential defenses against the towering creatures that roamed the earth. The architectural designs, building materials, and construction techniques used in these wonders would have been adapted to meet the dual purposes of awe-inspiring grandeur and practical protection. The pyramids of Giza, for example, might have been designed not only as tombs for the pharaohs, but also as fortified refuges against the threat of dinosaurs. Their massive stone blocks, already formidable in size, could have been further reinforced to withstand potential impacts from dinosaurs, making them impregnable fortresses in times of danger. The steep, sloping sides of the pyramids would have served as an additional defense, deterring large creatures from approaching too closely or scaling the structures. Inside, the pyramids might have contained secure chambers for storage of food, water, and other necessities, allowing people to shelter within the thick walls until the danger passed. Similarly, the Great Wall of China, originally constructed to protect against invading armies, would have been even more massive and impenetrable if it had also been intended to keep dinosaurs at bay. The wall's height and thickness would have been increased to create a barrier that even the largest dinosaurs could not breach. Watchtowers along the wall would have been equipped with advanced signaling systems to alert nearby garrisons and settlements of approaching dinosaurs, ensuring a swift response to any threat. The wall might have also incorporated additional defensive features, such as moats or steep embankments, to prevent dinosaurs from reaching the base of the structure. The construction of these wonders would have required not only immense labor and resources, but also a deep understanding of the behavior and capabilities of the dinosaurs they were meant to deter. Ancient engineers and architects would have studied these creatures closely, learning how they moved, what materials could best withstand their force, and how to design structures that minimized the risk of attack. This knowledge would have been passed down through generations, becoming an integral part of the architectural traditions of these civilizations. The scale and complexity of these projects would have also reflected the collective efforts of entire societies, with the construction of such wonders serving as a unifying force. The need to protect against dinosaurs would have brought communities together, fostering a sense of shared purpose and identity. The labor force that built these wonders might have included not only skilled workers and engineers, but also hunters, scouts, and naturalists who provided critical insights into how best to fortify these structures. Culturally, these wonders would have taken on additional layers of meaning. Beyond their roles as tombs, fortresses, or walls, they would have been seen as symbols of humanity's resilience and determination to survive in a world where dinosaurs posed a constant threat. Stories and legends about the construction of these wonders would have been infused with tales of bravery, innovation, and the struggle to protect loved ones from the dangers lurking beyond the city walls. The completion of such projects would have been celebrated with grand ceremonies, marking not just the physical accomplishment, but also the triumph of human ingenuity over the challenges posed by nature. In this alternate history, the pyramids, the Great Wall, and other ancient wonders would have stood as enduring testaments to the ways in which human civilization adapted to coexist with dinosaurs. These structures, built with both beauty and defense in mind, would have shaped the development of the cultures that created them, leaving a legacy that celebrated both the power of human creativity and the formidable challenges of living in a world shared with ancient giants. If armies had to consider the presence of dinosaurs on the battlefield, warfare would have evolved into a highly strategic and adaptive practice, with military tactics, weapons, and even the composition of armies profoundly influenced by the need to account for these massive and unpredictable creatures. The presence of dinosaurs would have added a new dimension to warfare, where commanding officers would have to factor in not only their human enemies, but also the potential dangers posed by dinosaurs that could suddenly turn the tide of battle. In this alternate history, armies would have been trained to use the environment to their advantage, learning to lure or avoid dinosaurs depending on the situation. Battlefield strategies would likely include plans for drawing dinosaurs into enemy ranks, turning these formidable beasts into unwitting allies. Commanders might have developed tactics that involved using noise, fire, or bait to direct dinosaurs toward opposing forces, creating chaos and forcing the enemy to divide their attention between the human combatants and the rampaging creatures. The design of weapons and armor would have also been influenced by the need to defend against dinosaurs. Soldiers might have been equipped with reinforced armor capable of withstanding the crushing bites or powerful swipes of these animals. Weapons could have been designed to exploit the vulnerabilities of dinosaurs, such as spears and arrows, with specialized tips to penetrate thick hides or nets and traps to immobilize smaller but still dangerous species. Siege weapons, like catapults and ballistae, might have been adapted to target larger dinosaurs directly, providing a means of neutralizing the threat they posed on the battlefield. Military formations and movements would have been adapted to minimize the risk of dinosaur attacks. Armies might have deployed in tight, disciplined formations that could quickly reorient themselves to face a charging dinosaur, using shields and pikes to create barriers that even the most aggressive creatures would hesitate to breach. Alternatively, skirmishers and light cavalry could have been employed to distract or herd dinosaurs away from the main force, keeping the creatures at a safe distance while the bulk of the army focused on its human opponents. Logistical considerations would have played a crucial role in planning military campaigns. Armies on the move would need to secure safe routes through dinosaur-inhabited territories, relying on scouts and trackers with deep knowledge of dinosaur behavior to avoid ambushes or surprise encounters. Camps would have been fortified with defensive structures designed to keep dinosaurs at bay, and sentries would have been trained to recognize the signs of approaching dinosaurs, ready to sound the alarm at the first hint of danger. The presence of dinosaurs could have also influenced the broader strategies of warfare, with generals and rulers considering the risks and opportunities presented by these creatures when planning their campaigns. Certain regions might have been considered too dangerous to invade or occupy, leaving them as natural buffers between rival states. Alternatively, control over areas with particularly fearsome dinosaur populations could have been seen as a strategic advantage, allowing one side to use these regions as a defensive barrier or as a source of living weapons that could be unleashed on the enemy. The psychological impact of dinosaurs on warfare would have been significant as well. The fear and unpredictability associated with these creatures could have been used as a tool of intimidation, with armies leveraging the presence of dinosaurs to demoralize their opponents before a battle even began. Propaganda and legends might have grown around certain commanders or units known for their ability to control or defeat dinosaurs, elevating them to almost mythic status within their societies. In this world, warfare would have been a complex interplay between human ingenuity and the forces of nature, with the presence of dinosaurs adding a layer of uncertainty and danger to every conflict. The evolution of military tactics, weapons, and strategies would have been shaped by the need to coexist with these ancient creatures, leading to a form of warfare that was as much about survival and adaptation as it was about defeating human foes. This would have created a dynamic and unpredictable battlefield, where the outcome of a battle could hinge not just on the skill of the soldiers or the plans of the generals, but also on the behavior of the dinosaurs that roamed the land. If ancient civilizations had captured and trained dinosaurs for use in war, agriculture, or transportation, the trajectory of human history would have taken a dramatic turn, with these massive creatures becoming integral to the development of societies, economies, and cultures. The domestication and training of dinosaurs would have revolutionized many aspects of life, transforming how ancient peoples built their civilizations and interacted with their environment. In warfare, dinosaurs would have been formidable assets, changing the dynamics of battle and military strategy. Imagine armies marching into battle with trained dinosaurs at the forefront, using their size and strength to break enemy lines or crush fortifications. Triceratops, with its massive horns and armored frill, might have been used as a living battering ram, capable of charging through enemy defenses. Meanwhile, smaller but agile carnivorous dinosaurs could have been trained to act as fast, deadly scouts or even as hunters, released to disrupt enemy formations and spread fear among opposing troops. The sight of a T-Rex or another colossal predator entering the battlefield would have been enough to demoralize any enemy force, making dinosaurs not just physical weapons, but psychological ones as well. In agriculture, dinosaurs would have played a critical role in transforming the landscape and boosting productivity. Large herbivorous dinosaurs, like Brachiosaurus or Ankylosaurus, could have been harnessed to plow vast fields, clearing land and turning soil on a scale unimaginable with traditional methods. Their ability to pull heavy loads would have made them invaluable for moving large stones or uprooting trees, paving the way for the construction of infrastructure and expansive farmland. Additionally, dinosaurs could have been used in irrigation projects, with their strength applied to operate water wheels or pumps, ensuring a steady supply of water to crops and helping to support larger populations. For transportation, the domestication of dinosaurs would have led to the development of new modes of travel, both on land and potentially even in water. Large, docile dinosaurs like Stegosaurus might have been fitted with saddles or harnesses, allowing them to carry people, goods, and supplies over long distances. These dinosaurs would have been the ancient equivalent of freight trains or caravans, moving vast quantities of materials across continents. For more specialized tasks, smaller, faster dinosaurs could have served as messengers or light transport, rapidly conveying important information or goods between distant locations. The integration of dinosaurs into daily life would have also influenced the social and cultural fabric of these civilizations. The ownership and training of certain dinosaurs might have become a symbol of wealth and power, with rulers and elites showcasing their most impressive creatures as a display of their status. Rituals, festivals, and religious ceremonies could have been centered around these creatures, celebrating their strength, revering their presence, and asking for their protection in times of need. Art, literature, and mythology would have flourished with stories and depictions of heroic deeds involving dinosaurs, embedding these creatures deeply into the cultural identity of these societies. The impact on urban planning and architecture would have been profound as well. Cities and towns might have been designed with dinosaurs in mind, incorporating wide streets, large stables, and specialized training grounds. Fortifications could have been built with defensive perimeters that accommodated the presence of these massive animals, and infrastructure like bridges and roads would have needed to support their weight and movement. The logistics of managing and caring for such creatures would have led to advancements in veterinary medicine and animal husbandry, with specialized professions emerging to cater to the needs of dinosaurs. In this alternate history, the domestication and training of dinosaurs would have been a cornerstone of ancient civilizations, driving technological, social, and economic developments in ways that shaped the course of human history. The powerful symbiosis between humans and these ancient giants would have created societies that were both awe-inspiring and formidable, with dinosaurs playing a central role in the rise and success of some of the most influential cultures in history. This world would have been one where the line between nature and civilization was blurred, as humans harnessed the might of dinosaurs to build, conquer, and thrive. If dinosaurs had posed significant threats to settlers and explorers, the processes of exploration and colonization would have been profoundly altered, with humanity's expansion into new territories slowed and made far more perilous. The presence of these massive, dangerous creatures would have necessitated a completely different approach to both exploring unknown lands and establishing new colonies, with an emphasis on caution, defense, and survival. Explorers venturing into uncharted regions would have needed to be equipped not only with the tools of navigation and survival, but also with weapons and defenses capable of fending off dinosaur attacks. Expeditions would have likely included skilled hunters and soldiers trained to protect against these formidable predators, and scouting parties would have been essential for assessing the dangers of new areas before larger groups moved in. Maps and reports from explorers would have been valued not just for detailing the terrain and resources, but also for identifying regions where dinosaurs were most prevalent, guiding future expeditions away from the most dangerous areas. The establishment of new colonies would have required meticulous planning and the construction of fortified settlements designed to withstand dinosaur incursions. Colonists would have had to build thick walls, sturdy gates, and lookout towers to protect themselves and their livestock from these threats. The layout of these colonies might have been influenced by the need to create defensible spaces, with buildings clustered together for mutual protection and common areas designed to allow quick and efficient defense. Settlements might have been strategically placed near natural barriers, such as rivers, cliffs, or dense forests, which could help to deter or slow down approaching dinosaurs. The presence of dinosaurs would have also impacted the pace of colonization. The risk of encountering these creatures would have made it more difficult to quickly establish and expand new territories, leading to a more gradual and cautious approach. Colonies would have been smaller, more self-sufficient, and heavily fortified until the surrounding area could be thoroughly explored and deemed safe. The need to secure territory against dinosaur threats would have made the process of claiming and developing land more labor-intensive and time-consuming, with a focus on ensuring the long-term viability and safety of each new settlement. Trade and communication between colonies would have faced similar challenges, as overland routes would have needed to account for the dangers posed by dinosaurs. Caravans and messengers traveling between settlements would have been heavily guarded, and routes would have been chosen based on the relative safety of the terrain. The threat of dinosaur attacks might have led to the development of more sophisticated transportation methods, such as heavily armored wagons or even the use of rivers and coastlines for safer travel, bypassing dangerous overland paths. The psychological impact of dinosaurs on explorers and settlers would have been significant as well. The constant threat of encountering a creature capable of devastating an entire settlement would have instilled a sense of caution and respect for the natural world. Folklore and stories about the dangers faced by early colonists might have become an integral part of the cultural memory of these societies, reinforcing the importance of vigilance and preparedness. In some cases, the presence of dinosaurs could have deterred colonization altogether, leaving certain regions untouched by human development. These areas, rich in natural resources but dominated by dangerous wildlife, might have remained as wild frontiers, only explored and exploited at great risk. Alternatively, these regions could have become the focus of specialized expeditions aimed at taming or controlling the dinosaur populations, using advanced technology or new strategies to make the land safe for human habitation. In this alternate history, exploration and colonization would have been shaped by the need to navigate a world where dinosaurs posed a significant and ongoing threat. The challenges presented by these creatures would have slowed human expansion, leading to the development of more resilient and defensive strategies for establishing new territories. The legacy of these early efforts would have influenced the way societies grew and interacted with their environment, creating a world where the balance between human ambition and the natural world was always delicately maintained. If the study of dinosaurs had begun in ancient times, leading to an earlier understanding of paleontology and biology, the course of scientific development would have been significantly accelerated, with profound impacts on human knowledge, culture, and technological advancement. Ancient civilizations, upon discovering dinosaur fossils, might have initially interpreted these remains as evidence of mythical creatures or divine beings, but with systematic study, they would have eventually recognized them as remnants of a distant past, sparking the early development of paleontology. Imagine scholars in ancient Egypt, Greece, or China unearthing dinosaur bones and dedicating themselves to understanding these colossal creatures. The discovery of these fossils would have intrigued ancient scientists who, driven by curiosity, might have established early methods of excavation, documentation, and classification. This could have led to the formation of the first museums or collections, where bones and artifacts were studied and preserved for public education and scholarly debate. As ancient scholars delved deeper into the study of these fossils, they would have started to develop theories about the history of life on Earth, laying the groundwork for concepts like extinction, evolution, and deep time long before these ideas emerged in the modern era. These early insights into the natural world might have influenced the development of biology, with ancient civilizations recognizing that life on Earth had changed dramatically over millions of years and that the creatures of the past were vastly different from those of the present. The early study of dinosaurs would have also spurred technological innovations. To excavate, preserve, and analyze fossils, ancient scientists would have needed to develop specialized tools and techniques, pushing the boundaries of engineering and craftsmanship. This could have led to advancements in materials science, as new methods were devised to handle and protect these fragile and ancient remains. Additionally, the desire to share knowledge about these discoveries might have encouraged the creation of more sophisticated methods of communication and record-keeping, such as detailed illustrations, early forms of printing, or even more precise written languages. Culturally, the understanding of dinosaurs as ancient creatures rather than mythical beasts would have reshaped myths, religions, and worldviews. The knowledge that giant reptiles once roamed the earth might have led to new narratives in religious texts or inspired epic tales that mixed historical understanding with mythological themes. Philosophers and theologians would have grappled with the implications of these findings, perhaps leading to early debates about the nature of life, the history of the earth, and humanity's place in the natural order. In education, the study of fossils and ancient life forms would have become an integral part of the curriculum, with young scholars learning about the history of life on Earth, alongside traditional subjects like mathematics, rhetoric, and philosophy. This early integration of natural history into education would have cultivated a deeper respect for the scientific method and encouraged generations of thinkers to explore the natural world with a rigorous and analytical mindset. The influence of paleontology on other fields of science would have been profound as well. Early insights into the biology and anatomy of dinosaurs might have led to a more advanced understanding of comparative anatomy, influencing the study of medicine and the development of early medical practices. The recognition of species diversity and adaptation in the fossil record could have spurred early ideas about evolution, influencing the way ancient scientists approached the study of living organisms. In this alternate history, the ancient study of dinosaurs would have sparked a scientific revolution long before the modern era, accelerating humanity's understanding of the natural world by centuries. This early embrace of paleontology and biology would have not only advanced scientific knowledge, but also shaped the cultural, technological, and philosophical development of civilizations, creating a world where the mysteries of the past were unraveled much sooner and with a deeper appreciation for the ancient history of our planet. If large dinosaurs still roamed the Earth, the discovery and use of fossil fuels would have been influenced by the unique challenges and opportunities presented by their presence. The existence of these massive creatures would have created a world where human progress, particularly in terms of energy resources, was shaped by the need to navigate a landscape shared with ancient giants. The process of discovering fossil fuels such as coal, oil, and natural gas would have likely been more complex and dangerous. Exploration and drilling activities would have required careful planning to avoid regions heavily populated by dinosaurs. This could have slowed the pace of fossil fuel extraction, as early prospectors and engineers developed specialized techniques and equipment to work in such hazardous conditions. The need to protect workers and infrastructure from potential dinosaur attacks might have led to the development of fortified drilling rigs, underground extraction methods, or even remote-controlled machinery designed to minimize human presence in dangerous areas. On the other hand, the presence of large dinosaurs might have accelerated the pursuit of fossil fuels as a means of advancing technology and infrastructure to deal with these creatures. The energy provided by fossil fuels would have been crucial in powering the machines, vehicles, and weapons needed to protect human settlements and facilitate safe transportation. The availability of abundant energy sources would have driven innovation in areas such as transportation, defense, and construction, leading to the rapid development of steam engines, armored vehicles, and fortified structures designed to withstand dinosaur incursions. The relationship between humans and dinosaurs could have also influenced the geographic distribution of fossil fuel extraction. Regions where dinosaurs were less prevalent or where natural barriers provided protection would have become key centers of fossil fuel production. These areas would have attracted workers, engineers, and entrepreneurs, leading to the growth of industrial hubs and the development of specialized industries focused on energy extraction and utilization. In terms of global trade and economics, the need to secure safe access to fossil fuel reserves would have played a central role in shaping geopolitical strategies. Nations and regions with abundant and accessible fossil fuels would have gained significant economic and military power, using their control over energy resources to influence global affairs. Alliances and conflicts could have arisen over the control of fossil fuel-rich territories, with the presence of dinosaurs adding an additional layer of complexity to these power struggles. The environmental impact of fossil fuel use in a world with large dinosaurs would have been significant as well. The extraction and burning of fossil fuels would have contributed to changes in the Earth's climate, potentially affecting the habitats and behavior of dinosaurs. As humans became more reliant on fossil fuels, they might have had to contend with the ecological consequences of their actions, leading to efforts to balance energy production with the preservation of the natural world. In this alternate history, the discovery and use of fossil fuels would have been deeply intertwined with the challenges posed by coexisting with dinosaurs. The need for energy to power technologies that protected and expanded human civilization in such a world would have driven both innovation and conflict. Fossil fuels would have been not just a resource, but a critical factor in humanity's ability to thrive in a landscape shared with some of the most powerful creatures to ever walk the Earth. The legacy of this dynamic would have shaped the course of human history, influencing everything from industrial development to global politics and environmental stewardship. If modern urban planning and architecture had evolved under the constant threat of dinosaur incursions, the design and structure of cities would be fundamentally different, prioritizing defense, adaptability, and the seamless integration of human and natural environments. Cities would have been built with a focus on minimizing the risks posed by these massive creatures while still allowing for the efficient functioning of urban life. The layout of cities would have been meticulously planned to create defensive perimeters capable of withstanding the force and unpredictability of dinosaur attacks. Massive walls, similar to medieval fortifications but constructed with advanced materials and techniques, would have surrounded urban areas, providing the first line of defense. These walls would be equipped with lookout towers, sensor systems, and automated defense mechanisms designed to detect and deter approaching dinosaurs. In some cases, natural barriers like rivers, cliffs, or dense forests would have been incorporated into city planning to create additional layers of protection. Within these fortified boundaries, the architecture of buildings would reflect the need for both safety and functionality. Skyscrapers and high-rise buildings might have been constructed with reinforced foundations and external structures capable of withstanding impacts, while lower buildings could be designed with sloping roofs or angled walls to discourage dinosaurs from climbing or leaning against them. The materials used in construction would have been selected for their durability, with an emphasis on reinforced concrete, steel, and other strong, resilient compounds. Public spaces such as parks, plazas, and transportation hubs would have been designed with multifunctionality in mind, serving as both gathering places and emergency shelters in the event of a dinosaur incursion. These spaces might include retractable barriers or shelters that could be deployed quickly to protect people and property. Underground infrastructure would have played a significant role, with extensive networks of tunnels, subways, and emergency shelters allowing for safe and rapid movement throughout the city, even during a dinosaur threat. Transportation systems would have been engineered to minimize exposure to dinosaur-prone areas. Elevated trains, monorails, and bulletproof buses could have become standard, keeping commuters out of reach of ground-based threats. Roads and highways might be designed with escape routes and fortified overpasses, allowing vehicles to bypass dangerous zones quickly. Bridges and tunnels connecting different parts of the city would be heavily reinforced, ensuring they could withstand the impact of a large dinosaur or serve as evacuation routes during emergencies. Urban green spaces would have been carefully managed to create buffers between human habitats and areas where dinosaurs might roam. These green spaces could include dense forests or thick vegetation designed to slow down or divert dinosaurs away from populated areas. Additionally, urban planners might have designated specific zones where dinosaurs could coexist with humans under controlled conditions, creating nature reserves or parks that served both as habitats for these creatures and as recreational areas for the public. Architectural innovation would have extended to residential areas, where homes would be built with safety features integrated into their design. Houses might include reinforced basements or panic rooms, while apartment complexes could have shared communal shelters or escape routes. The design of neighborhoods would prioritize accessibility and quick evacuation, with clear signage, communication systems, and designated safe zones. The presence of dinosaurs would also influence the cultural and social fabric of urban life. Public art and architecture might reflect the coexistence with these creatures, with sculptures, murals, and monuments dedicated to the history of human-dinosaur interaction. Schools and educational institutions would incorporate the study of dinosaurs and urban safety into their curricula, teaching future generations how to live safely and harmoniously in a world where dinosaurs still roam. In this alternate reality, modern urban planning and architecture would have evolved to meet the challenges of coexisting with dinosaurs, resulting in cities that are both resilient and adaptable. The need to protect against these ancient creatures would have driven innovation in design, construction, and technology, creating urban environments that are not only safe but also uniquely tailored to the demands of a world where humans and dinosaurs share the landscape. If the Industrial Revolution had been influenced by the availability of dinosaur-based resources, such as bones or skin, the course of technological and economic development would have taken on a unique character, with these ancient materials playing a central role in the innovations and industries of the time. The vast size and strength of dinosaur bones, coupled with the durability of their skin, would have provided early industrialists with new possibilities for manufacturing and construction, driving advancements in ways that were unimaginable before. Dinosaur bones, known for their immense size and density, would have quickly become a sought-after material for creating everything from building frameworks to machinery components. These bones could have been processed into structural elements, replacing or reinforcing wood, stone, or even early forms of metal. The bones' natural resilience would have made them ideal for use in large-scale constructions such as bridges, railways, and factory buildings. Architects and engineers might have designed structures that capitalized on the unique properties of dinosaur bones, resulting in buildings and infrastructure that were not only functional but also striking in appearance, with bone-based beams and supports becoming a signature of the industrial era. In addition to their use in construction, dinosaur bones could have been ground into powders and mixed with other materials to create new composites or used in the production of cement and other building materials. This would have led to the development of stronger, more durable products. pushing the boundaries of what was possible in manufacturing. Factories might have been outfitted with machines that incorporated dinosaur bones as key components, from gears and levers to support structures, creating a distinct industrial aesthetic defined by the fusion of ancient and modern materials. Dinosaur skin, known for its toughness and flexibility, would have found numerous applications in the burgeoning industries of the time. Tanners and leather workers would have developed specialized techniques to process dinosaur hides, producing a range of products from heavy-duty clothing and protective gear to industrial belts and conveyor systems. The use of dinosaur leather would have extended to military equipment as well, with armor and shields made from this material offering unparalleled protection to soldiers, potentially influencing the outcomes of conflicts during this period. The availability of these resources would have also sparked new industries focused on the extraction, processing, and distribution of dinosaur materials. Mining operations, already a cornerstone of the Industrial Revolution, would have expanded to include the excavation of dinosaur remains, with specialized tools and methods developed to efficiently harvest bones and skins from the earth. This could have led to the establishment of entire towns and communities centered around the dinosaur resource trade, with economies built on the supply of these valuable materials to factories and workshops across the world. The cultural impact of using dinosaur-based resources would have been significant as well. As these materials became more integrated into daily life, they would have influenced art, fashion, and design, with dinosaur-inspired motifs and products becoming symbols of modernity and progress. The fascination with dinosaurs would have permeated popular culture, inspiring everything from literature and theater to public exhibitions and educational programs. Museums dedicated to showcasing the industrial applications of dinosaur materials would have emerged, drawing crowds eager to see the incredible transformation of these ancient creatures into the building blocks of the modern world. This reliance on dinosaur-based resources would have also had environmental and ethical implications, as the extraction and use of these materials could have led to debates about conservation, sustainability, and the impact on ecosystems where dinosaur remains were found. The Industrial Revolution, driven by the availability of these resources, might have prompted early discussions about the responsible use of natural materials and the preservation of our planet's history, influencing the development of environmental consciousness and stewardship. In this alternate scenario, the Industrial Revolution, shaped by the use of dinosaur bones and skin, would have given rise to a world where ancient resources powered modern advancements, creating a unique blend of the prehistoric and the industrial. This integration of dinosaur-based materials into the fabric of society would have not only accelerated technological progress, but also left a lasting legacy in the cultural and economic landscapes of the time. If dinosaurs still competed with livestock in modern agriculture, the entire landscape of food production would have evolved to accommodate this unique challenge. Farmers would have needed to adapt their practices to protect their crops and animals from these massive, ancient competitors, leading to innovations in agriculture that balanced the needs of both human society and the presence of dinosaurs. Fencing and barriers would have been among the most significant developments in response to the threat posed by dinosaurs. Traditional fencing would not have been sufficient to keep these large creatures out of grazing areas, so farmers would have constructed reinforced barriers, possibly made from a combination of metal, stone, and advanced materials designed to withstand the force of a dinosaur trying to breach them. These barriers would need to be both tall and strong, creating secure enclosures where livestock could graze without the risk of being trampled or eaten by roaming dinosaurs. In areas where certain dinosaur species were known to be particularly aggressive or persistent, farmers might have employed deterrent systems such as electric fences, sonic devices, or even chemical repellents that dinosaurs found unpleasant. These measures would have been crucial for protecting valuable livestock and ensuring that food production could continue without constant disruption. The presence of dinosaurs would have also influenced the layout and planning of agricultural lands. Crops might be grown in areas that were less accessible to dinosaurs, such as on elevated terraces or within walled gardens. In regions where dinosaurs were particularly prevalent, farmers could have shifted towards more vertical farming techniques, using structures that kept crops out of reach of ground-dwelling dinosaurs. This shift would have likely led to advancements in hydroponics and aeroponics, as these methods would allow for controlled, intensive agriculture in smaller, more secure spaces. Livestock management would have required special attention with the development of fortified barns and shelters to keep animals safe at night or during periods when dinosaurs were known to be active. Herding practices might have evolved to include the use of trained animals or even mechanized drones to guide livestock away from danger, ensuring that herds remained safe and productive. In areas where large herbivorous dinosaurs were common, livestock might have been moved to higher ground or into more secure pastures during the growing season to minimize competition for grazing land. The competition with dinosaurs would have also influenced the types of animals that were domesticated and bred for agriculture. Farmers might have selected for livestock that could either coexist with dinosaurs or that were particularly resilient and adaptable in the face of these challenges. This could have led to the domestication of more robust, agile, or defensive animals, with breeds specifically developed to thrive in environments where dinosaurs posed a constant threat. On a broader scale, the presence of dinosaurs would have driven innovations in food storage and transportation. With the need to protect crops and livestock from dinosaur incursions, farmers and agricultural companies might have developed more secure and durable storage facilities, as well as specialized transport vehicles capable of withstanding attacks or avoiding areas where dinosaurs were known to roam. The cultural impact of dinosaurs on agriculture would have been significant as well, influencing the way people thought about food production and the environment. Farming communities might have developed unique traditions, stories, and practices centered around their relationship with these ancient creatures, celebrating the ingenuity and resilience required to farm in such a challenging landscape. In this alternate world, modern agriculture and food production would have been shaped by the need to coexist with dinosaurs, leading to a range of innovative practices and technologies designed to ensure the safety and productivity of farms. The constant presence of dinosaurs would have added an extra layer of complexity to food production, driving advancements that not only protected crops and livestock, but also pushed the boundaries of agricultural science and technology. The result would be a highly adaptable, resilient agricultural system capable of thriving in a world where humans and dinosaurs shared the land. If dinosaurs had been used in early scientific experiments, the trajectory of advancements in biology and genetics would have taken a fascinating and perhaps accelerated path. The study of living dinosaurs would have provided an unprecedented opportunity to understand complex biological systems, leading to early breakthroughs in fields such as comparative anatomy, genetics, and evolutionary biology. Imagine the impact of scientists in the 18th or 19th centuries having access to living dinosaurs for study. These creatures, with their unique physiological traits and massive sizes, would have presented a wealth of information that could have reshaped foundational concepts in biology. Early biologists would have been eager to dissect and analyze these ancient animals, comparing their anatomy to that of modern species. This comparative approach could have led to a more rapid understanding of evolutionary processes, perhaps even sparking earlier debates and discoveries related to natural selection and adaptation. The study of dinosaur genetics would have opened up entirely new avenues of research. The possibility of extracting and analyzing DNA from these creatures, or even breeding them in controlled environments, could have led to early experiments in genetics that predated the discoveries of Mendel and Darwin. Scientists might have explored the genetic differences between dinosaurs and modern animals, leading to the identification of genes responsible for specific traits like size, strength, or longevity. This could have accelerated the development of genetic engineering, with scientists experimenting with cross-species breeding or gene manipulation to create hybrids or to understand the genetic basis of certain characteristics. The use of dinosaurs in scientific experiments would have also influenced the development of medical research. Understanding the immune systems, regenerative capabilities, or unique biological processes of dinosaurs could have inspired early efforts to apply this knowledge to human medicine. For instance, if dinosaurs exhibited unusual healing properties or resistance to diseases, scientists might have sought to replicate these traits in humans or other animals, leading to breakthroughs in immunology and regenerative medicine much earlier than in our timeline. Moreover, the ethical considerations surrounding the use of such large and potentially dangerous creatures in experiments would have likely sparked early discussions about animal rights and the moral implications of scientific research. The presence of dinosaurs in laboratories and research centers could have led to the establishment of ethical guidelines and regulations governing the treatment of experimental animals, shaping the way science approached the balance between discovery and humane treatment. Culturally, the integration of dinosaurs into scientific research would have captured the public imagination, leading to widespread fascination with these ancient beings. Museums and exhibitions dedicated to showcasing the results of dinosaur research would have attracted enormous crowds, with people eager to learn about the latest discoveries and the possibilities they opened up for understanding life on Earth. This public interest would have driven further funding and support for scientific research, accelerating the pace of discovery and innovation. In this alternate history, the use of dinosaurs in early scientific experiments would have pushed the boundaries of what was possible in biology and genetics, leading to a world where our understanding of life and its underlying mechanisms was both deeper and more advanced. The legacy of these experiments would have left a lasting impact on the development of science, influencing everything from medical treatments to the ethical standards that guide research today. If the development of transportation, such as trains and automobiles, had to account for dinosaur migration, the entire infrastructure of travel and transit would have been fundamentally different. Engineers and planners would have needed to create systems that were both robust enough to handle the physical challenges posed by large, roaming dinosaurs and flexible enough to adapt to the unpredictable patterns of these ancient creatures. Railways would have been designed with elevated tracks, built high above the ground to avoid interference from dinosaurs. These elevated tracks would not only protect trains from the dangers of a direct encounter with a large dinosaur, but also ensure that the movement of these creatures did not disrupt the flow of goods and passengers. The construction of such elevated railways would have required advanced engineering techniques, with bridges and viaducts spanning long distances to keep the tracks clear of any potential obstacles. In areas where it was impossible to build elevated tracks, tunnels might have been dug deep into the earth, providing a secure passageway for trains while allowing dinosaurs to migrate freely above. Automobile transportation would have faced similar challenges. Roads and highways would have been designed with sturdy barriers or elevated sections to prevent dinosaurs from wandering onto them. In regions where dinosaur migration was common, highways could have been built on massive stilts or enclosed within protective tunnels. These structures would not only safeguard drivers and passengers, but also minimize the risk of collisions or traffic disruptions caused by the sudden appearance of a large dinosaur on the road. Additionally, vehicles themselves might have been designed with reinforced frames and advanced sensors to detect and avoid dinosaurs, ensuring safe travel even in areas where these creatures were known to roam. The need to accommodate dinosaur migration would have also influenced the development of transportation networks and the placement of cities and towns. Urban planners would have avoided placing major transportation hubs or densely populated areas in the path of known migration routes. Instead, cities might have been strategically located in areas less frequented by dinosaurs, with transportation routes carefully mapped out to bypass these regions. This would have led to the creation of transportation corridors that connected safe zones, allowing for the efficient movement of people and goods, while minimizing the risks associated with dinosaur encounters. In addition to physical infrastructure, transportation systems would have incorporated real-time monitoring and communication networks to track dinosaur movements and provide timely updates to travelers. Stations, airports, and bus terminals would have been equipped with information boards and emergency alerts that notified travelers of any nearby dinosaur activity, allowing them to adjust their plans or take alternative routes as needed. In more remote areas, travelers might have relied on specialized apps or devices that provided real-time data on dinosaur locations, ensuring they could navigate safely through potentially hazardous areas. The cultural impact of designing transportation systems with dinosaurs in mind would have been profound. The presence of these creatures would have become a normal part of daily life, influencing everything from the design of vehicles and infrastructure to the way people planned their commutes or vacations. The challenge of coexisting with dinosaurs would have driven innovation in transportation technology, leading to the development of more advanced, resilient systems capable of adapting to a world where humans and dinosaurs shared the landscape. In this alternate history, the evolution of transportation would have been deeply intertwined with the need to navigate a world where dinosaurs roamed freely. The resulting infrastructure would have been a testament to human ingenuity and adaptability, creating a transportation network that was not only efficient and reliable, but also uniquely suited to the challenges of coexisting with these ancient giants. This would have led to a world where the rhythms of human travel and the natural migrations of dinosaurs were harmoniously integrated, shaping the way societies moved, connected, and interacted. If modern-day zoos and wildlife preserves included dinosaurs as part of their conservation efforts, the entire approach to animal care, habitat design, and visitor experience would have been transformed to accommodate these extraordinary creatures. The presence of dinosaurs would have required innovative thinking and advanced technology to ensure their well-being, while also providing the public with a safe and educational way to observe these ancient giants. Zoos would have become much more than just places to see animals. They would have evolved into high-tech, meticulously planned environments where the needs of dinosaurs were prioritized alongside those of other species. The habitats for dinosaurs would have been expansive, designed to replicate the ecosystems these creatures once roamed millions of years ago. These enclosures would have featured a variety of landscapes, from dense forests and open plains to swampy wetlands and rocky deserts, allowing dinosaurs to engage in natural behaviors as they would in the wild. The safety of both the dinosaurs and the visitors would have been paramount. Enclosures would have been designed with advanced barriers such as reinforced glass, electrified fences, and even moats, ensuring that these massive creatures could not accidentally or intentionally breach their boundaries. Viewing platforms and walkways for visitors would have been elevated or enclosed, providing stunning views of the dinosaurs without compromising safety. The layout of these exhibits would have carefully considered the behaviors and territorial needs of each species, with ample space to prevent overcrowding and stress. The care and feeding of dinosaurs would have been a complex operation requiring specialized knowledge and resources. Zoos would have employed teams of paleobiologists, veterinarians, and nutritionists who were experts in the dietary needs, health, and behavior of these ancient reptiles. Feeding schedules would have been tailored to the specific requirements of each species, with herbivores receiving large quantities of foliage, fruits, and vegetation, while carnivores were provided with carefully controlled amounts of meat. To stimulate natural hunting or foraging behaviors, food might have been hidden or dispersed throughout the enclosure, encouraging dinosaurs to search for their meals just as they would in the wild. Conservation efforts would have focused on preserving not just the dinosaurs themselves, but also the ecosystems they once inhabited. Zoos and wildlife preserves might have participated in breeding programs designed to increase the population of endangered dinosaur species, with a goal of eventually reintroducing these creatures into specially designated wildlife reserves. These reserves would have been vast, protected areas where dinosaurs could live in conditions that closely resembled their natural habitats, interacting with other species and contributing to the biodiversity of the region. The inclusion of dinosaurs in modern conservation efforts would have also sparked new educational opportunities. Zoos and preserves would have offered extensive educational programs, teaching visitors about the history of dinosaurs, their role in the Earth's ecosystems, and the importance of preserving their habitats. Interactive exhibits, guided tours, and virtual reality experiences might have been developed to immerse visitors in the world of dinosaurs, providing a deeper understanding of these creatures and their significance in the natural world. In addition to education, the presence of dinosaurs would have attracted significant public interest, making zoos and wildlife preserves major tourist destinations. The revenue generated from ticket sales, merchandise, and donations could have been reinvested into conservation initiatives, not only for dinosaurs, but for other endangered species as well. The global fascination with dinosaurs would have driven collaborations between zoos, research institutions, and conservation organizations, leading to new discoveries in paleontology, biology, and ecology. In this alternate reality, the integration of dinosaurs into modern-day zoos and wildlife preserves would have transformed these institutions into centers of conservation and education, where the past and present intersected in a dynamic and awe-inspiring way. The challenges and opportunities presented by caring for dinosaurs would have pushed the boundaries of what was possible in animal care and conservation, leading to a world where these ancient creatures were not only preserved but celebrated as vital members of the Earth's diverse tapestry of life. If dinosaurs were major attractions or threats, tourism and global travel would have been fundamentally transformed, balancing the allure of witnessing these incredible creatures with the risks they posed. Tourist destinations would have evolved to capitalize on the unique opportunity to observe dinosaurs in their natural habitats or controlled environments, creating a booming industry centered around these ancient giants. At the same time, the presence of dinosaurs as potential threats would have necessitated significant changes in how travel was conducted, with safety and security taking on heightened importance. Tourism centered around dinosaurs would have drawn millions of visitors to locations known for their dinosaur populations, much like modern-day safaris or wildlife expeditions. Dedicated parks, preserves, and even entire regions would have been established to allow tourists to experience dinosaurs up close, but in a controlled and safe manner. These destinations would offer guided tours led by experts, providing not only protection, but also in-depth knowledge about the various species of dinosaurs, their behaviors, and their ecosystems. The infrastructure around these attractions would have been highly developed, with luxury lodges, hotels, and observation decks built to offer panoramic views of the dinosaurs in their natural settings. The travel experience itself would have been shaped by the need to ensure the safety of tourists. Specialized vehicles, perhaps armored and equipped with advanced tracking and communication systems, would have been used to transport visitors through dinosaur-inhabited areas. Air travel might have included routes specifically designed to avoid regions where flying dinosaurs or particularly large species were known to roam, with airports featuring reinforced hangars and runways. The demand for safety would have driven innovation in transportation, with new technologies developed to mitigate the risks associated with traveling near dinosaurs. For those seeking thrills, extreme tourism would have emerged as a niche market, offering adrenaline-pumping experiences like tracking or photographing predators from a safe distance, or even participating in conservation efforts by helping to monitor dinosaur populations. These high-risk activities would have required extensive training and protective gear, with tours conducted by highly skilled guides familiar with the dangers of interacting with such formidable creatures. Conversely, the presence of dinosaurs as potential threats would have significantly impacted global travel, particularly in areas where these animals were not contained or managed. Certain regions might have been deemed too dangerous for casual travel, leading to the development of safe travel corridors or the complete isolation of these zones. Travel advisories and restrictions would be common, with governments issuing real-time updates on dinosaur activity to prevent accidents or incidents. In regions where dinosaurs were a known threat, cities and towns would have incorporated extensive security measures to protect both residents and visitors. This might include the construction of barriers, fortified transportation hubs, and emergency evacuation routes. Tourist accommodations would be built with reinforced materials, offering secure places to stay in areas where encounters with dinosaurs were a possibility. Travel agencies and tour operators would have needed to specialize in routes and experiences that maximize safety, often collaborating with local authorities to ensure the well-being of their clients. The cultural impact of dinosaurs on tourism and travel would have been profound. Destinations known for their dinosaur populations would have become iconic, much like the Grand Canyon or the Great Barrier Reef, with global recognition and a steady stream of visitors. Souvenirs, documentaries, and educational materials centered around dinosaurs would have become major industries, further fueling public interest and fascination with these creatures. The global economy would have felt the influence of this tourism, with certain regions thriving on the influx of travelers eager to see dinosaurs, while others might have struggled with the challenges posed by their presence. In this alternate world, tourism and global travel would have been inextricably linked with the existence of dinosaurs, creating a unique and dynamic industry where the wonders of the ancient world were accessible to modern-day explorers. The careful balance between attraction and threat would have defined the experiences of travelers, making each journey both an adventure and a testament to human ingenuity in navigating a world shared with these incredible creatures. If dinosaurs were still present in our world today, the existence of these powerful creatures would have necessitated the development of specialized laws and regulations designed to manage human-dinosaur interactions and ensure the protection of both the creatures and human populations. These laws would reflect the unique challenges posed by coexisting with such massive and potentially dangerous animals, leading to a legal framework that balanced conservation efforts with public safety. The first and perhaps most critical aspect of this regulatory environment would be the establishment of protected areas where dinosaurs could live without encroaching on human territories. Governments around the world would designate vast tracts of land as dinosaur reserves, akin to national parks, where human access would be strictly controlled. These areas would be off-limits for most commercial activities, and entry would be restricted to researchers, conservationists, and carefully monitored tourism. Laws would mandate the creation and maintenance of these reserves, with penalties for violations such as poaching or unauthorized access, being severe to deter any potential threats to both the dinosaurs and the ecosystem. Human-dinosaur interactions outside of these protected areas would be governed by a comprehensive set of regulations designed to prevent conflicts and ensure public safety. Urban planning and infrastructure development would require compliance with strict guidelines that minimize the risk of dinosaur encounters. This might include mandatory barriers such as reinforced fences or walls around communities near known dinosaur habitats, as well as protocols for dealing with unexpected dinosaur appearances in populated areas. Laws would likely require businesses and public spaces to have emergency plans in place, with regular drills and safety measures implemented to prepare for any potential incidents. Wildlife protection laws would also be adapted to address the unique needs of dinosaurs. These regulations would include prohibitions on hunting or capturing dinosaurs, with exceptions only granted for scientific research under tightly controlled conditions. The trade of dinosaur-related products, such as bones or skin, would be heavily regulated to prevent illegal exploitation and to ensure that any such activities do not threaten the survival of dinosaur populations. Conservation agencies would be tasked with monitoring dinosaur numbers, health, and habitats, using advanced technology and field research to maintain a delicate balance between preserving these creatures and managing their impact on human life. In addition to wildlife protection, laws would likely address the ethical considerations of human-dinosaur interactions. Ethical guidelines would be established to govern the treatment of dinosaurs in captivity, whether in zoos, research facilities, or specialized breeding programs. These guidelines would ensure that dinosaurs are provided with appropriate living conditions that replicate their natural habitats as closely as possible, and that they are treated with respect and care. Breeding programs would be closely regulated to prevent overpopulation or the creation of hybrids that could pose new risks. Public education would play a significant role in these laws, with governments mandating the inclusion of dinosaur safety and conservation awareness in school curricula. Campaigns to educate the public about how to safely coexist with dinosaurs, what to do in case of an encounter, and the importance of preserving these ancient creatures would be widespread. Community engagement programs might involve local residents in conservation efforts, fostering a sense of shared responsibility for the stewardship of dinosaurs. Finally, international cooperation would be essential in managing the global presence of dinosaurs. Treaties and agreements between nations would establish common standards for dinosaur protection, research, and tourism, ensuring that these creatures are respected and preserved across borders. Collaborative efforts could also include the sharing of research data, resources for managing dinosaur populations, and coordinated responses to cross-border incidents involving dinosaurs. In this alternate world, the presence of dinosaurs would have driven the creation of a complex legal and regulatory system designed to navigate the challenges of living alongside these remarkable creatures. The resulting laws and regulations would reflect humanity's commitment to both safety and conservation, creating a framework that allowed for the peaceful coexistence of humans and dinosaurs, while ensuring the protection of these ancient giants for future generations. If dinosaurs played a role in modern ecosystems, climate change and environmental policies would have been shaped by the need to account for the unique ecological impact of these massive creatures. The presence of dinosaurs would have added another layer of complexity to how governments, scientists, and environmental organizations approach the pressing issues of climate change and ecosystem management. Dinosaurs, as large and often dominant species within their habitats, would have played significant roles in carbon cycling, vegetation management, and the overall balance of ecosystems. Their activities, whether as herbivores that consumed vast amounts of plant matter or as carnivores that influenced the population dynamics of other species, would have had direct effects on the environment. Policymakers would need to consider these factors when developing strategies for reducing greenhouse gas emissions, managing forests, and preserving biodiversity. For example, the impact of herbivorous dinosaurs on vegetation would have been a critical consideration in climate policy. Large herbivores could both aid in carbon sequestration by promoting the growth of new plants and contribute to carbon release through the breakdown of plant matter. Environmental policies might have focused on maintaining a delicate balance, ensuring that dinosaur populations were managed in a way that maximized their positive contributions to carbon storage while minimizing any potential negative effects. This could have led to the establishment of protected areas where dinosaurs were allowed to roam freely, contributing to natural carbon cycles, or to the development of specific land management practices that accounted for the presence of these creatures. Similarly, the role of carnivorous dinosaurs in regulating prey populations would have been an important factor in maintaining healthy ecosystems. These predators would have influenced the distribution and behavior of other animals, with cascading effects on vegetation and soil health. Environmental policies might have emphasized the conservation of these apex predators, recognizing their role in sustaining balanced ecosystems and preventing overpopulation of certain species that could lead to habitat degradation. Climate change itself would have posed unique challenges for dinosaur conservation. As global temperatures rose and habitats shifted, dinosaurs, like other species, would have faced threats from habitat loss, changing food availability, and increased competition. Environmental policies would have needed to address the conservation of critical habitats, ensuring that dinosaurs could continue to thrive in a changing climate. This might have involved the creation of wildlife corridors that allowed dinosaurs to migrate between suitable habitats, or the restoration of degraded ecosystems to support their populations. Furthermore, the energy demands and agricultural practices needed to coexist with dinosaurs would have influenced climate policy. The construction of barriers, transportation infrastructure, and agricultural systems designed to accommodate these large creatures would have required significant energy inputs, likely prompting discussions about sustainable energy use and the environmental impacts of these activities. Policies might have promoted the use of renewable energy sources, efficient land use, and sustainable agricultural practices that minimize the carbon footprint of human-dinosaur coexistence. On a global scale, international cooperation would have been essential in managing the environmental impact of dinosaurs. Climate agreements and environmental treaties would have included provisions specifically addressing the role of dinosaurs in ecosystems, ensuring that countries worked together to protect these species and the habitats they depended on. Collaborative efforts might have focused on shared research, the development of conservation strategies, and the exchange of best practices for integrating dinosaurs into modern ecosystems. In this scenario, climate change and environmental policies would have been profoundly shaped by the presence of dinosaurs, leading to a world where the protection of these ancient creatures was intertwined with the broader goals of sustainability and environmental stewardship. The need to balance the ecological roles of dinosaurs with the challenges of climate change would have driven innovative approaches to conservation, land management, and energy use, creating a unique and dynamic framework for addressing the environmental issues of the modern era. If space exploration and the search for extraterrestrial life had been influenced by the ongoing study of dinosaurs on Earth, the trajectory of scientific inquiry and technological development in these fields would have taken a distinct and perhaps more interdisciplinary path. The fascination with dinosaurs, as ancient and complex organisms, would have sparked broader questions about the nature of life itself, both on our planet and beyond, leading to a unique approach to exploring the cosmos. The study of dinosaurs, with their diverse adaptations and long evolutionary history, would have inspired scientists to think deeply about the conditions necessary for life to thrive. This understanding would have informed the search for extraterrestrial life, guiding researchers to consider environments that might seem harsh or inhospitable by human standards, but could support life forms with adaptations similar to those of dinosaurs. The resilience of dinosaurs in various climates and ecosystems on Earth would have encouraged scientists to look for planets or moons with extreme environments, such as those with dense atmospheres, high levels of radiation, or significant geological activity, where life could potentially evolve in unexpected ways. And space exploration missions might have been designed with an emphasis on finding signs of life that resemble the complex ecosystems that once supported dinosaurs. For instance, missions to Mars or the icy moons of Jupiter and Saturn could have focused on detecting large-scale biological processes, such as the presence of extensive plant-like organisms or the fossilized remains of ancient large creatures. The tools and instruments used in these missions would have been influenced by paleontological techniques, with rovers and landers equipped to dig deep into the soil, analyze rock formations, and identify fossilized structures that could indicate past life. The possibility of finding extraterrestrial life with similarities to Earth's dinosaurs would have driven the development of advanced life detection technologies. These technologies might include sophisticated imaging systems capable of identifying large, complex organisms from orbit or sensors designed to detect the chemical signatures of biological activity on distant planets. The study of dinosaur biology would have informed the design of these instruments, ensuring they were sensitive to the types of biomarkers that large, ancient life forms might leave behind. The ongoing study of dinosaurs would have also influenced the philosophical and ethical discussions surrounding space exploration. The realization that Earth once harbored such magnificent and diverse life forms could have reinforced the idea that life, in all its forms, is precious and should be protected. This perspective would have shaped how humanity approached the exploration of other worlds, with an emphasis on avoiding contamination and preserving any potential extraterrestrial ecosystems. Policies and guidelines for planetary protection would have been developed with the understanding that we are not just searching for microbes or simple organisms, but could encounter complex, perhaps even sentient life forms that deserve respect and care. Public interest in space exploration would have been heightened by the connection to dinosaurs. The idea of discovering alien creatures with similarities to the dinosaurs of Earth would have captured the imagination of people worldwide, leading to increased support for space programs and a greater focus on astrobiology in education and media. Documentaries, books, and films might explore the parallels between Earth's prehistoric past and the potential for similar life on other planets, making space exploration a topic of widespread fascination and debate. In this alternate history, the study of dinosaurs would have provided a powerful lens through which humanity viewed the cosmos, driving both scientific curiosity and ethical considerations in the search for extraterrestrial life. The lessons learned from Earth's ancient giants would have informed the strategies and technologies used in space exploration, leading to a more nuanced and holistic approach to understanding life beyond our planet. The result would be a space program deeply connected to our planet's history, with the quest to discover life in the universe intertwined with the awe and wonder inspired by the dinosaurs that once roamed the Earth. If scientists had the opportunity to work with living dinosaurs, advancements in genetic engineering and cloning would have taken a dramatically different path, potentially accelerating the field while introducing new ethical and technical challenges. The presence of dinosaurs would have provided researchers with an unprecedented opportunity to study and manipulate the genomes of these ancient creatures, leading to breakthroughs that could redefine our understanding of biology and genetics. The ability to analyze and sequence the DNA of living dinosaurs would have opened up new avenues for genetic research, particularly in understanding the mechanisms of evolution, adaptation, and longevity. Scientists would have been eager to uncover the genetic secrets that allowed dinosaurs to thrive in diverse environments millions of years ago. This research could have led to the identification of genes responsible for traits like rapid growth, resistance to disease, or the ability to survive in extreme conditions. These discoveries would have had far-reaching implications, potentially informing genetic engineering efforts aimed at enhancing human health, agricultural productivity, and environmental resilience. Cloning technology, already a topic of significant interest, would have been propelled to new heights with the possibility of cloning dinosaurs. The challenges of cloning large, complex organisms like dinosaurs would have pushed the boundaries of current techniques, leading to advancements in somatic cell nuclear transfer, artificial wombs, and even the development of entirely new cloning methods. The successful cloning of a dinosaur would have been a landmark achievement, demonstrating the potential to bring extinct species back to life and prompting debates about the ethical implications of de-extinction. The study of living dinosaurs would have also influenced the development of gene editing technologies like CRISPR. Scientists would have sought to understand how specific genetic sequences contributed to the unique characteristics of dinosaurs, leading to more precise and targeted gene editing techniques. These advancements could have been applied to a wide range of fields, from medicine to agriculture, enabling the creation of genetically modified organisms with traits inspired by dinosaurs, such as enhanced strength, durability, or longevity. However, the ethical considerations surrounding genetic engineering and cloning would have been profoundly impacted by the presence of dinosaurs. The prospect of manipulating the genomes of such iconic and powerful creatures would have raised questions about the limits of scientific intervention and the responsibilities of researchers. Public debates would have focused on whether it was appropriate to clone or genetically engineer dinosaurs for research, entertainment, or even commercial purposes. The possibility of creating hybrid species, part dinosaur, part modern animal, would have sparked intense discussions about the potential consequences and the moral implications of playing with nature on such a grand scale. Regulatory frameworks would have emerged to govern the use of genetic engineering and cloning technologies, particularly in relation to dinosaurs. Governments and international bodies would have established guidelines to ensure that research was conducted ethically and that the potential risks to both humans and the environment were carefully managed. These regulations might have included strict controls on cloning, limitations on the creation of hybrid species, and protocols for the care and management of genetically engineered dinosaurs. The cultural impact of genetic engineering and cloning in a world with living dinosaurs would have been significant as well. The public's fascination with dinosaurs, combined with the possibilities offered by genetic technology, would have fueled a surge of interest in science and biotechnology. This interest would have been reflected in popular media, with films, books, and documentaries exploring the implications of bringing dinosaurs back to life and the potential for using their genetics to solve modern problems. The presence of dinosaurs would have made genetic engineering a topic of everyday conversation, shaping public perceptions and driving demand for education and transparency in the field. In this alternate scenario, the intersection of dinosaurs and genetic technology would have led to rapid advancements in cloning and genetic engineering, while also raising important ethical and societal questions. The lessons learned from working with dinosaurs would have influenced the direction of scientific research, pushing the boundaries of what is possible while challenging humanity to consider the consequences of our technological capabilities. This would have created a world where the past and future of life on Earth were inextricably linked, with the mysteries of dinosaurs guiding the evolution of genetic science. If future human societies evolved alongside intelligent dinosaur species, the development of a shared civilization would have profoundly altered the course of history, culture, and technology. The coexistence of humans and intelligent dinosaurs would have required a deep understanding and respect for each species' unique strengths and perspectives, leading to a society that blended the instincts, traditions, and innovations of both. From the beginning, the emergence of intelligent dinosaurs would have challenged humans to rethink their place in the world. The concept of humanity as the dominant species on Earth would have been replaced with a more complex social dynamic, where cooperation and competition between species shaped every aspect of life. Communication would have been crucial, with both species developing sophisticated ways to understand and interact with each other. This could have led to the creation of new languages or the enhancement of existing ones to bridge the gap between human and dinosaur thought processes. Governments and political systems would have evolved to include both humans and dinosaurs in decision-making processes. Early alliances might have been formed out of necessity, as both species recognized the benefits of working together to overcome environmental challenges, manage resources, and defend against common threats. Over time, these alliances would have deepened into a more integrated society with shared governance structures where humans and dinosaurs held leadership roles and contributed equally to the direction of their civilization. The technological landscape of this shared civilization would have reflected the unique capabilities of both species. Dinosaurs, with their different physical forms and senses, might have developed technologies that complemented human inventions, leading to innovations that neither species could have achieved alone. For example, dinosaurs with heightened senses of smell or hearing might have contributed to advancements in detection and surveillance technologies, while their physical strength could have inspired new forms of construction and transportation. This cross-species collaboration would have accelerated technological progress, creating a civilization with a diverse and advanced technological base. Cultural exchange between humans and dinosaurs would have been rich and varied, leading to the development of a hybrid culture that celebrated the traditions and achievements of both species. Art, music, and literature would have drawn from the experiences and histories of humans and dinosaurs alike, creating a vibrant cultural tapestry. Festivals and rituals might have been held to honor the shared history of the two species, commemorating key moments of cooperation and mutual respect. The idea of a shared civilization would have been deeply embedded in the social consciousness, with both humans and dinosaurs contributing to a collective identity that transcended species boundaries. Education systems would have been designed to cater to the needs and learning styles of both species, with schools and universities offering curricula that integrated knowledge from human and dinosaur perspectives. Young humans and dinosaurs would have learned side by side, gaining insights from each other's experiences and developing a sense of unity and shared purpose from an early age. This education would have emphasized the importance of cooperation, empathy, and understanding, preparing future generations to continue building a society where both species could thrive. The presence of intelligent dinosaurs would have also influenced environmental policies and conservation efforts. The shared civilization would have recognized the importance of preserving the natural habitats and ecosystems that both species depended on, leading to a more sustainable approach to resource management. This focus on sustainability would have been reflected in urban planning, agriculture, and industry, with technologies and practices designed to minimize environmental impact and promote harmony between human and dinosaur communities. Religion and philosophy would have been profoundly impacted by the coexistence of two intelligent species. Spiritual beliefs might have evolved to include reverence for both human and dinosaur contributions to the world, with deities, myths, and moral codes reflecting the shared values and experiences of the two species. Philosophical debates would have explored the nature of intelligence, consciousness, and the ethical implications of living alongside another sentient species, leading to new schools of thought that enrich the intellectual life of the civilization. In this alternate reality, the evolution of a shared civilization between humans and intelligent dinosaurs would have led to a world where diversity was not only accepted, but celebrated as a source of strength and innovation. The challenges of coexistence would have been met with creativity, empathy, and a commitment to building a society where both species could flourish. This unique civilization would have stood as a testament to the power of collaboration, demonstrating that even the most different of beings can find common ground and create a future that honors the best of both worlds. If dinosaurs had continued to evolve alongside humans, the Earth's biodiversity in the distant future would be far more complex and diverse, with ecosystems that blended ancient lineages with modern species. The presence of evolving dinosaurs would have created unique interactions within ecosystems, leading to the development of new species and the adaptation of existing ones in response to the pressures exerted by these formidable creatures. In this scenario, dinosaurs would have adapted to changing environments over millions of years, potentially giving rise to entirely new species with traits that allowed them to coexist with humans and other modern animals. Some dinosaurs might have evolved to fill niches similar to those occupied by large mammals today, such as large herbivores grazing in open plains or apex predators hunting in dense forests. These new dinosaur species would have developed alongside mammals, birds, and reptiles, leading to intricate food webs and predator-prey relationships that blended elements of both ancient and modern ecosystems. The coexistence of humans and dinosaurs would have also influenced the evolution of other species. Animals that interacted with dinosaurs, whether as prey, competitors, or symbiotic partners, would have developed adaptations to survive and thrive in a world where these ancient creatures were still present. For example, large mammals might have evolved stronger defensive traits, such as thicker hides or enhanced agility, to avoid predation by evolving dinosaur species. Similarly, smaller animals could have developed specialized behaviors or physical features that allowed them to exploit resources in areas less accessible to dinosaurs, such as dense undergrowth or high tree canopies. Plant life would have evolved in response to the presence of both dinosaurs and humans, leading to a diverse range of flora adapted to withstand or capitalize on the behaviors of these creatures. Trees and other vegetation might have developed tougher bark, deeper root systems, or other features to survive the feeding habits of large herbivorous dinosaurs. Meanwhile, plants that relied on dinosaurs for seed dispersal or pollination could have evolved to maintain those relationships, ensuring their continued survival in this dynamic environment. Human influence on the environment, such as agriculture, urbanization, and climate change, would have been shaped by the need to accommodate the presence of dinosaurs. Humans might have developed agricultural practices that integrated dinosaurs into the farming ecosystem, using herbivorous species to clear land or manage vegetation. Urban areas would have been designed with the understanding that dinosaurs were part of the natural landscape, leading to cities and infrastructure that minimized conflicts with these creatures while preserving their habitats. The ongoing evolution of dinosaurs would have also driven innovations in conservation and environmental management. Efforts to protect endangered dinosaur species or restore their habitats would have been a major focus of environmental policy, with humans working to balance the needs of these ancient creatures with those of other species and ecosystems. Conservation strategies would have included measures to protect critical habitats, manage human-wildlife interactions, and ensure the long-term survival of both dinosaurs and modern species. In the distant future, the Earth's biodiversity would be characterized by the coexistence of species from different evolutionary eras, creating ecosystems that were both familiar and profoundly different from those we know today. The interaction between evolving dinosaurs, modern animals, and humans would have led to a rich tapestry of life, with unique species and ecological relationships that reflected millions of years of shared history. This biodiversity would have been a testament to the resilience and adaptability of life on Earth, demonstrating how species can continue to evolve and thrive in a world shaped by both ancient and modern forces. In this world, the study of biology and ecology would have been deeply influenced by the need to understand the complex dynamics of ecosystems that included both dinosaurs and modern species. Scientists would have explored how these creatures adapted to changing environments, how they interacted with other species, and how their presence shaped the evolution of life on Earth. The knowledge gained from studying these interactions would have informed conservation efforts, helping to preserve the Earth's biodiversity for future generations. Overall, the Earth's biodiversity in a future where dinosaurs continued to evolve alongside humans would be a unique and vibrant reflection of the planet's long evolutionary history, blending ancient and modern elements into a dynamic and interconnected web of life. If the presence of dinosaurs had led to entirely different global political structures, the organization of nations and regions would have been fundamentally shaped by the need to manage and coexist with these formidable creatures. The ability to effectively handle dinosaur populations would have become a key factor in determining political power, regional stability, and economic prosperity. Regions rich in dinosaur populations would likely have developed specialized governments or administrative bodies focused on managing these creatures, integrating them into the social, economic, and environmental fabric of their societies. These governments would have been tasked with ensuring the safety of their citizens while also harnessing the economic potential that dinosaurs could provide, whether through tourism, agriculture, or other industries. The expertise required to manage dinosaurs effectively would have led to the rise of a new class of political leaders, those with backgrounds in ecology, biology, and environmental management, whose knowledge and skills were critical for maintaining regional stability. Global political alliances and conflicts would have revolved around the control and protection of regions with significant dinosaur populations. Nations or regions that could demonstrate effective management of these creatures would have gained considerable influence on the world stage, as their expertise would be sought after by others facing similar challenges. This could have led to the formation of international coalitions or organizations dedicated to the sharing of knowledge, resources, and technologies related to dinosaur management, similar to how organizations like the United Nations coordinate global efforts in areas like health and security today. Economic power would have been closely tied to a region's ability to capitalize on its dinosaur populations. Areas with abundant dinosaurs might have developed thriving economies based on tourism, attracting visitors from around the world eager to experience these ancient creatures up close. Additionally, regions that could domesticate or utilize dinosaurs in agriculture, transportation, or other industries would have gained a significant economic advantage, leading to the development of specialized sectors and trade networks centered around dinosaur-related products and services. The presence of dinosaurs would have also influenced the cultural and social structures within these regions. Societies would have been organized around the realities of living alongside dinosaurs, with cities and communities designed to minimize conflicts and maximize safety. Cultural practices, traditions, and even legal systems would have evolved to reflect the importance of dinosaurs in daily life, with rituals, festivals, and ceremonies celebrating the relationship between humans and these ancient creatures. In regions where dinosaurs posed significant threats, governance might have taken on a more militarized or authoritarian character, with strict laws and regulations governing human behavior and interaction with these creatures. Governments in these areas would have invested heavily in security forces, technology, and infrastructure designed to protect their populations from dinosaur-related dangers. This could have led to the development of highly centralized command and control political systems where authority was concentrated in the hands of leaders or organizations that could guarantee the safety and stability of the region. Conversely, regions that had successfully integrated dinosaurs into their ecosystems and economies might have developed more decentralized, collaborative forms of governance. These areas would have prioritized sustainability, conservation, and the equitable distribution of resources, creating political structures that emphasized community involvement and the collective management of natural assets. This approach could have led to the formation of regional alliances based on shared ecological goals, with member states working together to manage their dinosaur populations and preserve their environments. On a global scale, the presence of dinosaurs would have redefined traditional concepts of sovereignty and territorial control. Borders and political boundaries might have been drawn not just based on human cultural or historical factors, but also on the natural ranges and habitats of dinosaur populations. International diplomacy would have included negotiations over the management of cross-border dinosaur migrations, the allocation of resources for conservation efforts, and the coordination of response strategies in the event of a dinosaur-related crisis. In this world, global political structures would have been deeply influenced by the need to coexist with dinosaurs, leading to a new paradigm of governance where the ability to manage these creatures was as important as military might or economic power. The challenges and opportunities presented by dinosaurs would have driven the evolution of political systems that were uniquely adapted to the realities of a world where humans and ancient creatures shared the same space, creating a dynamic and interconnected global society shaped by the presence of these extraordinary beings. If artificial intelligence and robotics had been developed with the specific purpose of interacting with or managing dinosaurs, these technologies would have evolved in ways that prioritized adaptability, resilience, and sophisticated decision-making capabilities. The presence of dinosaurs would have imposed unique challenges on AI and robotics, driving advancements that might not have been realized in a world without these ancient creatures. From the outset, robotics would have been designed with a focus on durability and strength to withstand the physical demands of interacting with large, powerful dinosaurs. Robots built to manage or monitor these creatures would have needed to be incredibly robust, capable of operating in harsh environments, and equipped to handle the potential risks associated with close proximity to dinosaurs. This would have led to the development of machines with reinforced structures, advanced mobility, and self-repair capabilities, ensuring that they could continue to function even after sustaining damage from an accidental encounter with a dinosaur. Artificial intelligence, on the other hand, would have needed to be highly sophisticated to manage the unpredictable nature of dinosaur behavior. AI systems would have been trained to recognize and respond to a wide range of dinosaur actions and reactions, from tracking migration patterns to understanding signs of aggression or distress. These AI systems would have relied on vast datasets collected through years of observation, allowing them to make informed decisions in real time to prevent conflicts or guide dinosaurs safely through human-populated areas. The integration of AI and robotics would have resulted in the creation of autonomous systems capable of monitoring dinosaur populations, managing their habitats, and even facilitating interactions between dinosaurs and humans. These systems would have been deployed in wildlife reserves, urban environments, and agricultural settings, where they could monitor the movements of dinosaurs, ensure that boundaries were respected, and intervene if a dinosaur strayed too close to human activity. For example, autonomous drones equipped with AI could track herds of herbivorous dinosaurs, analyzing their migration patterns to predict their impact on local ecosystems or agricultural lands, while ground-based robots could guide these herds away from sensitive areas. In agriculture, robots designed to work alongside dinosaurs would have transformed traditional farming practices. These robots could manage large herbivorous dinosaurs, using AI to direct them to graze in specific areas, thereby maintaining the landscape and reducing the need for human intervention. Meanwhile, in more dangerous settings, such as protecting crops from carnivorous dinosaurs, AI-driven systems could deploy non-lethal deterrents to keep these predators at bay, ensuring the safety of both humans and dinosaurs without resorting to harmful measures. The presence of dinosaurs would have also influenced the development of AI and robotics in conservation efforts. AI systems would be critical in monitoring the health and well-being of dinosaur populations, using sensors and data analysis to detect changes in behavior, disease outbreaks, or environmental stresses. These systems could autonomously adjust conservation strategies, such as relocating dinosaurs to more suitable habitats or managing breeding programs to maintain genetic diversity. Robots might be employed in these efforts, conducting tasks that would be too dangerous or labor-intensive for humans, such as tagging or treating injured dinosaurs in the wild. In urban areas, AI and robotics would have played a vital role in ensuring that cities and towns could coexist with dinosaurs. AI-driven traffic management systems would monitor and redirect human and dinosaur movement to prevent accidents, while robotic systems could patrol city boundaries to keep dinosaurs from wandering into populated areas. Emergency response robots, equipped with AI, would be able to quickly assess and mitigate any situations where dinosaurs posed an immediate threat to human safety, using non-lethal methods to guide the creatures back to their natural habitats. Culturally, the presence of AI and robotics designed to manage dinosaurs would have sparked new discussions about the ethical use of technology in wildlife management. The balance between human safety, animal welfare, and environmental preservation would have been a central concern, with society grappling with the responsibilities that come with such powerful technologies. These debates would have shaped the development and deployment of AI and robotics, leading to a regulatory framework that ensured these systems were used ethically and sustainably. In this alternate reality, the development of artificial intelligence and robotics would have been deeply intertwined with the challenges of managing a world where humans and dinosaurs coexisted. The resulting technologies would have been robust, adaptive, and intelligent, capable of navigating the complexities of a world where the ancient and the modern intersected. These advancements would not only have transformed the way society interacted with dinosaurs, but also would have set new standards for the use of AI and robotics in managing the natural world. If future space colonization efforts had to consider the possibility of encountering dinosaur-like life forms on other planets, the entire approach to exploring and settling new worlds would be fundamentally altered. The potential presence of large, powerful, and possibly dangerous creatures would require a level of caution and preparation that would shape every aspect of space missions, from initial exploration to the establishment of permanent colonies. The first phase of space colonization would involve extensive reconnaissance and remote sensing to assess the environments of target planets. Advanced robotic probes and drones equipped with sophisticated sensors would be deployed to gather detailed information about the planet's ecosystems, paying particular attention to signs of large fauna. These probes would map out potential habitats, track movement patterns, and analyze the behaviors of any dinosaur-like creatures from a safe distance. The data collected would help scientists determine whether these planets could support human life and what precautions would be necessary. If dinosaur-like creatures were confirmed to exist, the design of habitats and colonies would prioritize defense and safety. Colonies would be built with strong, reinforced structures capable of withstanding the potential impacts from these massive creatures. Perimeters would be fortified with barriers and advanced detection systems to prevent unexpected encounters. These colonies would likely be designed to minimize their environmental footprint, reducing the chances of attracting the attention of local fauna. The layout of these settlements would be strategic, with buildings and infrastructure designed to allow for quick evacuation or defensive actions if necessary. Space colonization would also involve the development of new technologies specifically designed to manage interactions with these creatures. Robotics and AI would play a crucial role in monitoring and responding to the presence of dinosaur-like life forms. Autonomous drones would patrol the colony's surroundings, equipped with non-lethal deterrents to steer creatures away from human settlements. Ground-based robots might be used to study and, if necessary, relocate animals that pose a threat, ensuring the safety of the colonists while respecting the integrity of the planet's ecosystems. The potential for encountering such life forms would also influence the training and composition of the human crews involved in space colonization. Colonists would need to be equipped with skills in wildlife management, biology, and even paleontology, as understanding the behavior and biology of these creatures would be essential for coexistence. Specialized teams might be formed to handle interactions with local fauna, using their expertise to develop protocols for avoiding conflicts and maintaining a peaceful relationship with the planet's native species. Scientific research would be a key component of any colonization effort, with a strong focus on studying these dinosaur-like creatures. Understanding their physiology, behavior, and ecological roles would not only be critical for ensuring the safety of the colonists, but also for advancing our knowledge of extraterrestrial life. The discovery of such creatures would offer invaluable insights into the processes of evolution and adaptation in different planetary environments, potentially leading to breakthroughs in biology, ecology, and even medicine. Ethical considerations would be at the forefront of these efforts. The potential to disrupt or harm an alien ecosystem by introducing human activity would necessitate strict guidelines and international agreements on how to conduct space colonization responsibly. The preservation of native species and their habitats would be a priority, leading to the development of conservation strategies that balance the needs of human settlers with the protection of the planet's biodiversity. This ethical approach would influence every decision, from the initial selection of landing sites to the long-term management of the colony. The cultural impact of encountering dinosaur-like life forms on other planets would be profound. The existence of such creatures would capture the public imagination, inspiring a new era of exploration and storytelling. Books, films, and other media would explore the challenges and wonders of living alongside these ancient giants, blending science fiction with real-world possibilities. This fascination would drive public interest and support for space exploration, fueling further missions and the expansion of human presence across the galaxy. In this future scenario, space colonization would be a careful, deliberate process shaped by the need to coexist with powerful, potentially dangerous creatures. The presence of dinosaur-like life forms on other planets would lead to new technologies, ethical frameworks, and cultural narratives that reflected the complexities of exploring and settling new worlds. This approach would create a spacefaring civilization that was not only technologically advanced, but also deeply aware of the responsibilities that come with venturing into the unknown. If dinosaurs had continued to exist alongside humans throughout history, the impact on human art, culture, and storytelling would have been immense, weaving these ancient creatures into the very fabric of our collective imagination. Dinosaurs, as powerful symbols of the natural world, would have inspired countless myths, legends, and artistic expressions, becoming central figures in the way societies understood their place in the world. In art, dinosaurs would have been depicted in a wide variety of forms, from grand, majestic murals in ancient temples to detailed carvings and sculptures adorning public spaces. These creatures, with their imposing size and distinct features, would have been revered and feared, portrayed as both protectors and destroyers in the visual narratives of different cultures. The presence of dinosaurs in everyday life would have led to their representation in pottery, textiles, and jewelry, where they might symbolize strength, resilience, or the cycle of life and death. Over centuries, artistic styles would have evolved to reflect changing relationships between humans and dinosaurs, from ancient reverence to perhaps more modern depictions of coexistence and harmony. Culturally, dinosaurs would have been integral to the rituals, beliefs, and identities of various societies. Many civilizations would have developed elaborate mythologies surrounding these creatures, attributing them with divine or mystical powers. These myths might explain natural phenomena, such as earthquakes or storms, as the movements or battles of dinosaurs, with entire pantheons of gods and spirits connected to different species. Festivals and ceremonies dedicated to dinosaurs would have been common, with communities gathering to honor these creatures through dances, songs, and offerings. The stories of heroes who tamed or defeated dinosaurs would have been passed down through generations, becoming foundational legends in many cultures. In literature and storytelling, dinosaurs would have featured prominently in epic tales and moral parables. Ancient storytellers would have crafted narratives around the interactions between humans and dinosaurs, using these stories to convey lessons about courage, survival, and the relationship between humanity and nature. As societies evolved, these stories would have been recorded in manuscripts, performed in theaters, and eventually adapted into films and television. The genre of dinosaur fiction would have become a significant literary tradition, with works ranging from historical epics to speculative tales imagining future interactions between humans and dinosaurs. The continued presence of dinosaurs would have also influenced the development of symbols and metaphors in language. Dinosaurs, as embodiments of ancient power and endurance, would have been used as metaphors for timelessness, strength, and primal forces. Phrases and idioms derived from dinosaur behaviors or characteristics would have permeated everyday speech, enriching the language with references that connected people to these creatures. For example, a stubborn person might be described as having the will of a triceratops, or a complex situation might be likened to navigating a raptor's maze. Moreover, the influence of dinosaurs on culture would have extended to education and philosophy. Dinosaurs would have been studied not just as biological specimens, but as living symbols of the natural world's complexity and mystery. Philosophers might have pondered the ethical implications of sharing the planet with such powerful creatures, leading to schools of thought that emphasized coexistence, respect for nature, and the recognition of humanity's role within a broader ecological context. Educational systems would have integrated the study of dinosaurs into various disciplines, from natural sciences to ethics, fostering a deep understanding of these creatures and their significance in human history. As human societies advanced, the depiction of dinosaurs in popular culture would have continued to evolve, reflecting contemporary values, fears, and aspirations. In modern times, dinosaurs might be portrayed in media as allies in environmental conservation, symbolizing the need to protect the Earth's ancient heritage. Alternatively, they could be used in cautionary tales about the consequences of human hubris, highlighting the dangers of disrupting the natural balance. The enduring presence of dinosaurs would have ensured their constant relevance in art and culture, making them a timeless source of inspiration and reflection. In this world, the continued existence of dinosaurs would have shaped human art, culture, and storytelling in profound ways, making these creatures central to our understanding of the world and our place within it. Dinosaurs would have become more than just animals. They would be icons of power, wisdom, and the deep connections between all life forms across the ages. This rich cultural tapestry, woven with the threads of human-dinosaur interaction, would have created a unique and enduring legacy, influencing every aspect of human creativity and thought.